Maybe a couple of more students are joining. Okay, so what are we talking about right now? In the previous lecture, we have seen the construction of a direct reading compass. We have seen there is a compass liquid. We have seen we generally prefer to use vertical card compass. And we have seen what are the benefits of having certain type of construction. You have notes for the same. You must have gone through it. The main purpose of a direct reading compass is to indicate heading. Can be used as a primary instrument to indicate heading for a light aircraft. And for larger aircrafts, we can use it as a standby compass. Anything that is basic and fundamental, even if it's not going to be used, or if it is not still being used as a primary equipment, it is very important for us doing CPL to know it. And the reasons are explained every now and then. Why? Exams are centered around these topics, students, most of the times. In the exams, you will see there is a healthy balance. Okay. This healthy balance generally is between these instruments and what is it in use. What is it in use as primary systems majorly will be there in your ATPL more, as in those high-tech equipments related to fly-by-wire and all. The base would remain the same. Everything in CPL becomes a part of your ATPL. Okay. So I want you all to be very sure and thorough with all these concepts, not just magnetism, but everything that you learn here. These are your building blocks of the knowledge that you're gaining. So see if you have any questions. And if you don't have any questions, then we will just get started. Today's topic is one of those crucial topics that is actually, causing a lot of confusion in a student's mind if it is not clearly understood. So today we are going to see those in a very swift way, in a very simple way, wherein we can address the situation with respect to in-flight navigation also, and we can try to address the situation with respect to examination challenges, that is solving some type of questions. Write down the first point for today would be, writing down the first point, it would be the major limitations of a direct reading magnetic compass. Major limitations. There are 3 limitations that you will come across. All right. One of those limitations is what we are going to talk about today. The other deviation, of course, the other limitation is somewhere obviously related to what we call as deviation or something like that. If you have any questions, you will let me know. Okay. And be very careful about not learning a wrong thing. Take your time to clarify your understanding with respect to whatever concept you have. These things are highly competitive. You can score a lot of marks, but with respect to that, we can say that they will be subject to more silly errors. Questions will be very tricky in the exam. So tricky that we'll have to be very careful with respect to how we read it, how we relate it with respect to our understanding. and how we mark the correct answers. Ultimate goal will always be there to find the correct answer to a problem that you face. The problem in exams would be a numerical somewhere here and there. And the problem in real life would be to ensure that your navigation is accurate. Now, students, what is the primary requirement for your navigation to be accurate? The primary requirement is for you to stay on the track and for you to have the heading which you need to be on, have the capacity to stay on the same heading. Above everything else that the pilot can control, one of the few things that the pilot actually has in control, one of those things is the airspeed that I can increase or decrease using the thrust settings. Then maneuvering of the aircraft, whether I can turn right or left. And then what else do I have? The capacity to steer in any direction I want. Steering means turning right or turning left. That gives you a choice of selected headings. As a pilot, for me to navigate from departure to arrival, heading is the most important thing for me. It is not always necessary that my aircraft will fly in the direction where the heading is. Why? Because of certain crosswind effects. Any wind effect at the level that you're flying might make you experience some sort of drift. In order to allow for the drift, you make a change to your heading to stay on the required track. What does it mean? It means if there are no wind components, then my heading and my required track will be the same. But if there are wind components, my heading could differ. Still, the choice will be always with a choice of heading. Selecting the right heading, maintaining the right heading is the only way to enable the pilot to stay on the required track. Staying on the required track is very important. Number of ways. If you are not on track, you might not get air traffic services. If you don't have air traffic services, you can get lost. If you are getting lost, you might run out of fuel and you might not be able to safely land the aircraft. Another problem that can happen if you go off track is that you might come across areas, danger areas, restricted areas, prohibited areas, where it could cause further threat to your safety. You might unknowingly wander off into a hilly area or a bad weather area, and that could further increase the risks attached to your safety. Plus, if you are not on a planned track, you will not be in the vicinity of your planned alternates. So, in case of any emergency, you'll not be able to decide whether you are safe to go to a particular alternate or you're safe to go back to departure or proceed to your destination. For you as a pilot, and at the core of navigation generally becomes maintaining the correct heading or maintaining the required track. This is a secret that I'm sharing with you all. When you're completing towards mastering your general navigation or other aspects, even radio navigation, moreover, you will see your questions somewhere directly or indirectly will be centered around headings. All the topics that you have with respect to heading, required track, angle correction, track error angle correction, should be mastered first if you're preparing for final preparation. Even your radio navigation systems with respect to reading the instrument, something that we'll be doing very soon, are related to whether the pilot is able to stay on track or not, with respect to relative bearing, with respect to radials. So you have to understand that compass is that instrument that indicates the heading to the pilot. So it becomes a major source of information. The compass that we actually use in larger aircrafts is a remote indicating magnetic compass. That remote indicating magnetic compass that is being used in our 320, 737s, 321s, all aircrafts, it's a combination of a magnetic compass and a gyroscopic directional indicator. Okay. But before we go to the remote indicating magnetic compass, it becomes very important for a commercial pilot, a student, working towards getting a commercial pilot license to know about the errors in the direct reading magnetic compass, because that's your primary source when you're doing your flight training. Remember the 200 odd hours that you'll be flying, 200 or odd hours, like to 10 to 20 odd even, whatever. You will be majorly relying on those basic instruments that are actually standby instruments in your larger aircrafts. This is why it is important for you, because they, in the exams, the paper pattern is assumed in a way that you have also gone through flight training. Although you don't really need to go through flight training to appear and clear CPL exams. That's why we call it ground studies. It's something that you do on ground, clear, and then you go and fly. Best strategy. But it's okay. So right now, what I'm going to teach you with respect to the errors is somewhere going to be with respect to what effect is happening to the heading indication of a magnetic compass. The heading indication will be represented generally by the Lubber line. It is also called as a heading index on dials. It's a fixed index on the top of your instrument. But always the heading is referred with respect to where the north-seeking pole of the magnet assembly is pointing and whether it is in alignment with the magnetic north or not. If it is not in alignment with magnetic north, then we are not getting a correct reading. Errors in magnetic compass, especially in direct reading magnetic compass, are the same situation. Whenever there is a deflection with respect to the north-seeking pole of the magnet assembly and the actual magnetic north meridian with respect to that position, then my heading is not correct. And if the heading indicated to the pilot is not correct, the pilot might be following the incorrect heading, and that incorrect heading slowly will make the pilot deviate from the track. Once the deviation from the track will happen, chances of the pilots to experience any of the threats that I just spoke about are likely to increase and increase and increase. So we need to be aware about these errors, and then we need to be aware about how to understand these errors, how to reduce these errors. Now, generally, the errors that we're going to talk right now cannot be reduced or eliminated completely. So a pilot should be aware about it. And the pilot should know, okay, right now I'm doing this, so this error is there. I need to manipulate my understanding so that I can account for the error. Like I always say, aviation design of the aircraft and the instruments is a collective, it's a collective combination of some calculated sacrifices. So we learn to live with a lot of errors, but we tame those errors. That's why in every instrument, ADF, NDB, pitot-static systems, ASI, you will see errors is always an important part in the study of the particular topic. Why can we not reduce those errors to minimum? It's not possible. If it were to be made possible, our instrument would not be practically applicable to be used in an aircraft. So it's a good combination of what we can achieve and what we can compromise, healthy combination. So remember this logic here, and after that, if you address these errors, you will know that my ultimate goal is to maintain correct heading, but my compass during certain situations will not maintain correct headings. Those are the things that the pilot should be aware about. So write down limitations of a direct reading compass. I'll give you 3 statements. First one you will write, the DR compass is a self-contained instrument. The DR compass is a self-contained instrument and thus does not allow any provision and thus does not allow any provision to provide the magnetic heading indication to to other equipments of the aircraft. Now, this limitation, students, is given with respect to a major factor that we generally see applicable everywhere in an aircraft or a larger aircraft, that one system is used to provide information or energy or used to multiple systems. This is why your aircraft can actually, this is how aircraft can actually give you some profit to an airline. It is the secret in the design. Now, the basic example of this is that my engine, generally created to give me airspeed and thrust, my engine supplies auxiliary services also. Services like generation of the AC electricity, generation of the DC electricity, generation of the energy or the power required for air conditioning, generation of the energy or power required for hydraulics, and then generation of the energy or power required for air pressure systems like pneumatics. Everything will be derived from the engine only. And not just everything, in order to start the second engine, when you're having a twin engine, we take the drive from the first engine only. So we get one functioning done in the beginning through the help of APUs or batteries. We get one engine started, and through that engine, we get everything else for the aircraft. As long as the engine is running, we are getting everything else. Why do we do it? We do it because the engine is that particular equipment that is eating or drinking up or, taking a lot of fuel, and the fuel is the most expensive thing for us right now. So if the engine is taking so much of fuel and it's only going to give us thrust, is there a way to not compromise on the thrust but still get more and more out of the same? Yes, we get it through the accessory drive box. So we have certain gears attached to the mechanism of the engine. The gears pass on some rotary drives, and wherever you have rotary drive, you can have ultimate power generation. Examples are windmills. A windmill moving freely in air can give you electricity. How? Because it rotates. So if you can get a rotary motion, you can generate electricity. If you can generate electricity, you can generate or transfer the energy from one form to another. Similarly, this point explains that it would have been nice if my DR compass would have given the reference of magnetic heading to other instruments also, whatever the other instruments are. But sadly, it cannot do so. But the good thing is our remote indicating magnetic compass will be able to do that. So that is one of the advantages of that particular compass. Write down the second limitation of a DR compass. The sensing element of a DRMC is contained within the instrument, and that instrument has to be situated close to the pilot in the cockpit to get the indication of the heading. The area of the cockpit includes a lot of other equipment that are made up of ferrous metal, including electric lights, electric motors, etc., which all act as a source of deviation. So now, students, with this statement, you understand that a direct reading magnetic compass will be subjected to a lot of deviation also. Because one of the major factors is that the sensing element itself is situated in the cockpit, and my cockpit is filled with all other instruments that are going to increase the deviation. So although I can have residual deviation with respect to compass swing and everything, still it's still going to be a task for the pilot to all the time calculate deviation and apply it to get the magnetic heading. The job could be made easier is what we always try to achieve with respect to research. The third point, of course, something that is our subject of discussion today. Third error or third drawback or third limitation of DRMC, please write down. During linear acceleration and linear deceleration, linear as in just in one line, okay? During linear acceleration or linear deceleration, the compass does not give an accurate heading indication. The DRMC, the direct reading compass, the compass does not give a accurate heading indication. Next point you will write, during turns that occur every now and then, during turns that occur every now and then, the compass or the DRMC does not accurately indicate the heading. So the last point that you have written down, acceleration, deceleration, and turning, those are what we call as acceleration errors and turning errors. So the two things, DRMC being self-contained, okay, nothing can be done about it. It's like there only. Second thing, it is subject to more deviation. So we have corrected that also with using or reduced it with the compass swing and all. The only thing that we have not yet discussed is the acceleration and turning errors. So today we are going to talk about it. Learning of acceleration, deceleration error can be said to be done within a couple of levels of learning. With respect to CPL, I would say that we learn it with respect to how the turn would be and what would be the impact with respect to the indication to the pilot. The only part that will not be covering would be the part that I would say that would be the next level, which I think you should do it before your ATPL exams, or maybe once you're done learning what I'm showing you today, then you could just give the text a further read that talks about what is actually happening to the magnetic assembly, similar to what I was showing you in the pendulous suspension, having one bottom, one going up, CG, and pivot weight, something to do with that. So our job today would be to understand the impact of acceleration. When is it high? When is it low? And to understand the impact of turning errors. How does it affect the heading, and what should the pilot do to maintain the correct heading? Okay. A lot of important points. I would say this is going to be like a treasure box for you. Hardly you'll get 2 to 3 questions, even in one exam, out of all these points that I'm giving you today. But these points in itself can make up at least 20 to 30 questions, individual questions. If I want to turn them into complicated questions, I can create as many questions as I want for you. But sometimes the weightage could be only 2 to 3 out of what I'm teaching right now. Sometimes none, sometimes 5 to 7 also. So you study them thinking that 5 to 7 questions could be asked to me with respect to these. So that would be a requirement, because if you miss out on this topic and if you get an exam paper where you get majority, then you will know your a paper will not be for 100, but it will only for 90 then. And then again, your breathing room will be reduced. Any questions so far? Think about it. Yes, Muskan, go ahead.
Sir, can you please read back the second point?
The second point, students, is with respect to the compass being in the cockpit to enable the pilot to directly read the heading. And the cockpit is filled with a lot of other instruments and equipment. I'm just saying it in generic words. You can make your own sentence there. And those equipments generally are made up of ferrous material or ferrous metal, and they include electric lights, electric motors, which become a source of deviation to the magnet assembly. So we start the statement by saying the sensing element, that is the sensing element, magnetic sensing element in the compass, is subject to more deviation in a DRMC because the sensing element is directly in the cockpit itself. Why are we specifying this point here, students? Because remote indicating magnetic compass, the sensing element is kept in a place where there is the least influence of these ferrous metals or other equipments that can cause deviation. And what is that position? It is towards the wingtip or in the tail cone of the aircraft. So wingtip is generally where you will see your remote ending magnetic compass. Magnetic sensors are while the indication is in the cockpit. So we call it remote. Remote means doing something by being somewhere else. Remember, the remote word generally comes through remote villages. So villages that are very far away from the city and other urbanization. Then due to pandemic and all, we know remote learning. It means the class is somewhere else, but we are learning somewhere else. So here remote means sensing element is somewhere else, indication is in the cockpit. So that actually remote ending magnetic compass rectifies all the three drawbacks that we have discussed. It will not have turning acceleration errors. It can give data to all other equipment also. And it is subjected to the least deviation, zero deviation, we could say. Muskan, I hope you have written down the second point correctly.
Affirm, sir.
Good. Nakul, ready? Do you understand what's happening? Any doubts?
No, sir.
Sridhar, Likit.
No, sir.
No doubt, sir.
Remember, our job is to maintain a heading, correct heading. But during acceleration, deceleration, and during turning, my compass is not going to give me correct heading. So I need to know about it. And if I know exactly how I know about variation deviation, students, like let's say it's variation west magnetic west, let's say variation is 7 degrees. And if you want to maintain a true track or true heading of 200, then what would you follow on the magnetic compass? So you follow something else on the magnetic compass to stay on something else that is true. So in this case, we would follow 207 on the magnetic compass to stay on 200 true. Correct? So this is indirect alignment. We want 200, but we are aligning with 207 on magnetic compass. These acceleration, decelerations are just like that. If you want to maintain a heading or track of some value, then knowing the error will tell you when to or where to align your aircraft with respect to magnetic compass reading so that you stay on the required track or required heading. Simple. That is the ultimate goal. If you don't understand this with respect to ultimate goal, then you'll have a lot of struggle mastering these concepts because the whole reciprocal confusion will happen here. Okay. And the reciprocal confusion is something that I'm trying to sort directly. Still, if it comes to you, you can let me know. I'll tell you to just revisit the lecture again, read the notes couple of times. Slow and steady, you get there. So do not panic initially in the first session only. But yeah, you can get it, easily also. गुलशन, आज आपके क्लॉकवाइज एंटी क्लॉकवाइज के ऊपर नोट्स आने वाले हैं. उस पर ध्यान देना. कुछ डाउट्स होगा तो पूछ लेना. Chaitanya, I hope you're all focused, no distractions.
Yes, sir.
Okay, good. Rohita and Suchita, I hope no doubts with respect to what our ultimate goal is here. Ultimate goal again is to know what the errors would be in the magnetic compass indication during acceleration, deceleration. What is acceleration now? Let's say you are at a airspeed of 150 knots and your required airspeed that you have to do is 250 knots. So from 150 knots to 250 knots, you will start accelerating. So your changing velocity is what acceleration is all about. Changing velocity. And deceleration would be slowing down. Jyotsna, how do you read?
Read you 5, sir.
Good, good, good. So we are just getting started with our errors. First, we'll be doing acceleration errors. We'll be writing important points, and then we'll be doing deceleration error. Jyotsna, were you catching up on the initial part? If not, then after the session, you can do that. We've just been discussing the logical understanding of what and why. So make sure you do it later. But don't miss that, okay? It will help you understand these things more. Good, good, good. Very nice to see you. So students, what is acceleration and deceleration here? Again, acceleration is I'm increasing my velocity. Deceleration is I'm slowing down. When my aircraft is having a constant airspeed, then I'm not going to have acceleration, deceleration errors, okay? Then my compass is giving me correct heading. Whatever the indicated heading is the correct heading for me. All right? Let's hope that today the chat thing will work. Write out. Whenever the aircraft is accelerating or deaccelerating, it can be subjected to an inaccurate heading indication. It can be subjected to an inaccurate heading indication. This is called as an acceleration or a deceleration error for a DRMC, direct reading magnetic compass. Very simple. Okay. Now we are going to branch out our understanding. We're going to branch out our understanding with respect to acceleration error and deceleration error. Okay. It'll be a very good way for you to write down all the important elements. Okay. There will be some common points and some opposite points. Now, the first thing you can write is that now AE and D will put it as a short code for our understanding. Okay. So that when we are writing, we can be a little fast in making notes. Point number 1, you will write acceleration error is max on easterly or westerly heading. Now, the first thing, I can give you a question. Your heading is for a pilot to fly, acceleration error will be maximum on which of the headings? Option A, 0980. Option B, 100. Option C, 110. Here, with respect to this, you will say it is maximum on easterly or westerly heading. Easterly would mean 0980 as a more accurate answer. But if you talk about easterly, let's say this is your North Pole and this is Earth, that any direction you fly in the eastern hemisphere can be considered as your easterly heading. So generally, if we have to determine what are the sectors within which I would determine my heading is easterly, then I could say that what will help me will be my cardinal points and my quadrantal points. So I can say that 045, 135. Now, any heading between these can be considered as a easterly heading, majorly. Now, these are secrets to understand these points, okay? Make sure you know this carefully. All right. So, whenever I'm going easterly, my acceleration error in a DRMC is going to be maximum. So, I have to be careful. So, if I'm going from point A to point B, let's say I'm going to fly from Mumbai to Pune, it's going to be easterly heading for me. So I have to be careful whenever I'm accelerating or deaccelerating that I'll have certain heading indication which will not be accurate. That's it. So I have to be aware about it, and whatever errors are there should account for it. So I should basically depend on my magnetic indication only when I'm in a steady flight without any acceleration or deceleration, something like that. Okay, so anything between 045 to 135 majorly will be easterly. But if I have to compare other headings, let's say 010 and 030, so which will be more easterly in this regard? This will be easterly in this regard compared to this. So be very careful with respect to what kind of options do you get, because the reversal could happen when you don't go clockwise, but you go anti-clockwise like this. The second major reason or maximum of acceleration or acceleration we're talking about will happen on a westerly heading. So in the same case, what will be easterly heading? This sector, 225 to 315 generally. Majorly will be the western sector. So what does it mean? If this is western sector, then what sector is this? This sector I can say would be northerly for me. And similarly, this sector here I can say will be southern. Like this. Now, this is something that can really help you quickly come to certain questions and answers in a generic way. Otherwise, what happens when I don't show you this? You will just think easterly, westerly means 0980 or 270. 0980 and 270, it will be max. Reducing from 0980 up to 045, it will reduce. Again, increasing from 0900 to 135, it will reduce. Comparing to 0900. So it will be maximum at 0900 heading and maximum at 270 heading, that is westerly heading. Anywhere going towards here or there, it will reduce. By the time you reach poles, acceleration error and deceleration error will be 0. Sometimes somebody in future could ask you to explain what is happening to the magnet inside. It is there in the notes I will share, but you do it once you have completed everything in your CPL. Okay. So write down about deceleration error. The first point about deceleration error. Deceleration, how you want to call it. Deceleration error is maximum. These abbreviations are just for us, okay? Other places they are not using these abbreviations. This is for our shortcut writing, DEAE, okay? Our shortcuts. Deceleration error is max on easterly or westerly heading. Same impact with respect to increasing. You'll write note. Going away from 0900 or 270, AE will decrease and will become 0 on northern or southern headings. Write down the same point for deceleration error also. So here you can write going away from 0900 or 270. Remember in both directions, okay? Deceleration error will decrease and will become 0 on northern or southern headings. Any doubts? नुकुल समझ आ रहा है नहीं आ रहा है? हाँ ना, क्या बोल रहे हो? मैंने देखा नहीं आपको.
यस सर आ रहा है.
वेरी गुड. चैतन्य आप कहाँ हो? वीडियो नहीं ऑन कर रहे हो?
Yes, sir, इधर ही.
Second point you will write, acceleration error is 0 on northern or southern headings. And same point for deceleration error also. Deceleration error is 0 on northern and southern headings. And you can see it increases as your heading would increase easterly or westerly and will become maximum at 0900 or 270. Exams will give you any sort of statement. It cannot be directly given to you in a class, you know. It might be like that, it might not be like that. So for you to understand it is very important rather than memorizing it. Because if you understand, then you can tackle any question. If you memorize, then you'll have to memorize 100 to 200 questions just on one topic. That's why when students who just do question banks for 2000 questions, they face it very difficult to clear in their first attempts because they just depend upon the chances of the same questions repeating, which would be once in every 5 attempts, I would say. So they'll have to give cash paper again and again, spend 10, 20,000 just on exams and then finally clear. What's the point? You didn't get the knowledge, you wasted so much of time, plus you wasted so much of money. Now let's consider specific headings in specific hemispheres. Okay. Write down on 270 magnetic heading in northern hemisphere. Okay. Um, so we'll write it in a better way here. Like this. A common point we'll write here for both acceleration and deceleration. Like this. Point number 3. If I'm in the northern hemisphere and I'm going in a westerly heading, so what would be the impact of my acceleration error? And what would be the impact of my deceleration error? Got the situation, students? First, imagine where you are. You're in the northern hemisphere. It means you're above the equator. Okay. And you're going in a westerly direction. If you'll be accelerating, what would be the error in the heading? If you'll be deaccelerating, what would be the error in the heading? Okay. Deaccelerating will not mean going back. Okay. It'll just mean slowing down. Acceleration will mean picking up speed. Like when you see a speed breaker, if you're riding a cycle, bike, driving a car, you slow down. That's deceleration. When you see an empty highway or a signal is freed, you increase the speed. That is acceleration. So on 270, magnetic heading in the northern hemisphere, you will write your compass overreads in acceleration error. Okay. In deceleration error, you will write compass underreads. Compass overreads, compass underreads. A lot of questions will be like that. How would it mean for you? For you, it would be like if you want to stay on a heading, let's say 250, and if you are accelerating on a westerly heading, let's say 250, right? If you are accelerating in the northern hemisphere to maintain 250, your compass will be overreading. It means you will not be on an actual 250, you will be on a lesser heading than 250. So the compass is overreading. So for you to be on 250, you might have to choose a higher reading, something like that. If the question is there that tells you what is the moment of the compass card or the magnet assembly, so you will write compass card moves anti-clockwise. CW is for clockwise. Now, later on, I will give you a very shortcut where I'll tell you a couple of statements that whenever movement is clockwise, we get underreading. Whenever movement is anti-clockwise, we get overreading. With respect to deceleration error, you write a point that there is an apparent turn indication. Apparent turn as in we tend to think that we have turned in a particular direction, but we have not actually turned in the particular direction. Whenever it is under reading, our apparent turn is going towards south. It means going left. Why left, students? Again, this is 270. This is 0980. If I have to maintain 250, okay, in deceleration, my compass is under reading. It means if my aircraft is on 250, my actual indication will be lesser. Okay. So the choices here would be such that the pilot would seem that my turn is going towards the southern hemisphere or the southern pole. Just write these points for now carefully. Deceleration error in the northern hemisphere on a heading of 270. So these are the points you'll have to remember. Northern hemisphere heading 270, deceleration error, compass will underread, and the apparent turn will be south. And here, for acceleration error, you will write apparent turn is towards the north. Overreads, it's reading extra, means it is going clockwise to the right, that is to the north. Underread, it is reading lesser, it means it's going towards the south. That is the meaning, same. This point here, you will add when you go through the notes, okay, in your reading task. This point here, spot it and write it. That's it. Remember. Just look for it, whether it will state in the notes that during deceleration, is my compass card moving clockwise? Compass card, or I could say the magnet assembly. Both would mean the same over here for me. Just like yesterday, we were discussing how the card is attached in the last class on the magnet assembly. Okay. So this will be acceleration will overread towards north, apparent turn, deceleration will underread towards south, like this. Very simple. Even if I want to be on 270, acceleration error will show me probably 310 and a turn that I have turned there. And deceleration, if let's say 270 is my choice or required heading, deceleration will underread and deceleration will show me 250 over here. So I have to be very careful. So the pilot would choose. In turning errors, you will see how would the pilot choose which heading to be on to stay on that particular required heading. So this is the apparent turn. This towards north. This is overreading. Acceleration, deceleration. Now don't get confused. I've not made the equator here, okay? Otherwise you'll think, sir, apne to southern hemisphere banaya. Not made the equator here. Just showing this an example. We'll say we all are in the northern hemisphere only. Now write down the second heading in the northern hemisphere. Heading 0980 magnetic in northern hemisphere. So here also we'll write number 1 with respect to heading. And here we'll write number 2 with respect to heading. So we are now easterly in the northern hemisphere. Let's go back and study what is the impact. This is point number 4 for us. Or this 1 that you have written, you can just write 3 also, like 3.1. Like, I don't know how it's going to be helpful to you. 3 is fine, I think. Yeah, and here you can write 4 like this. 4 is fine. Point number 4. And again, individualized point number 4 like this. Heading 0980, what is happening to my compass is underread, overread, apparent turn. That's it. Acceleration errors will have only these major points now. Okay. Heading 0980, magnetic. First point, my compass underreads or overreads. My compass will underread during acceleration error. During deceleration error, the opposite will happen. My compass would overread. Okay. Second point, my compass card, what will be the movement of my compass card? Remember, technique is very simple to remember. Above we saw anti-clockwise overreads. Let's see if this rule applies everywhere. Okay. It is underreading. What does it mean? It means it is not anti-clockwise. So it'll be clockwise. Compass card moves clockwise. Now, this is a shortcut I'll be building up, a strategy I'll be building up for you to easily remember movement of compass card or magnetic assembly and underread or overread. A simple way to understand. So, Gulshan, I think starting with you, I'll be asking a couple of questions to see whether whether we still have any confusion or not. Simple. Okay. OR means overread over here. Okay. You just write overread if you don't like these shortcuts. So will the compass overread when the compass card or magnet assembly? This also you will add when you go through the notes. Okay. It's gonna be true only with respect to what I'm saying, but still. Third point, apparent turn. Where would the apparent turn be? Apparent turn, you would say north, acceleration error in the northern hemisphere in 0900, and for the acceleration error, and for deceleration error, apparent turn south. Same. Mirror image, you could say. Mirror image of 270, 0900. So north and south are same. Just clockwise, anti-clockwise is changing.
It's opposite.
Sorry?
The compass will underread, so current turn will be south, right?
See,
Got it, sir. Got it.
here students, clockwise overreading is happening, anti-clockwise underreading is happening, because let's say I want to maintain 0900, then underread will be probably 070 and overread will be 110. So if I'm overreading, my apparent turn looking towards south, and if I'm underreading, my apparent turn looks towards north. Remember this diagram, student. Nobody in the world has this in these ground training things. You'll be the only ones who would be very skilled at it with the best strategy. You can always revisit the lecture once more to understand. Likit, you got it by checking the same thing that I made, right? How did you get it without me explaining?
So actually, I thought I remember the direction 090.
Students, it's very important to visualize the realistic heading. Otherwise, if you memorize, it can happen that you will be confused every now and then. That's why I made this diagram for you to simply understand it. That's why I've given you the sectors also to understand what easterly and westerly would be. And here the reciprocal confusion that I talk about will never happen if you visualize like this. So Likit, you tell me what was your understanding? I like that you have resolved your doubt. Just explain how did you figure it out in your mind? That was very quick to happen, right? Just share with me.
Well, actually, I was relating to the last point here.
So that is reciprocal, right? 270, 0980. So confusion will happen. So things will be partial, things will be same, partial things will be opposite. This is why students face a lot of difficulty all across the planet, not just in India, learning these concepts. So we cannot just stick to one explanation and verify everything from that. We have to study all and look at the common points, remember the common points, and look at the uncommon points and remember the uncommon points, like that. Very good, very good. Anybody else has any doubt? See, on a easterly heading, if I go left, I'll be decreasing. If I go right, I'll be increasing. On a westerly heading, if I go left, I'll be decreasing. If I go right, I'll be increasing. My directions only, nothing else. Correct? Now the same thing you're going to experience in turning errors also. When you're going from the North Pole, your directions, bigger directions are decreasing. And when you're going right turn from the North Pole, they look like the logical thing. Okay, zero se start ho raha hai, बढ़ रहा hai. When you go like this, the confusion will happen. And those are the questions that are asked in the exams. Good, good. No problem. Going good, everyone. Point number 5, you will write with respect to heading. Heading on 270 degrees magnetic in southern hemisphere. Okay. Compass underreads compass card or the magnet assembly clockwise, and apparent turn is towards south. I would want you all to try and make this diagram and share it with me if you can. No pressure. If you don't want to do it, don't do it. Anybody who wants to try doing it can do and share it with me. Deceleration error in the southern hemisphere on a westerly heading. Why are we talking about hemispheres here? Because in the northern hemisphere, more influence would be with respect to North Pole. In the southern hemisphere, more influence would be with respect to the South Pole. So a certain change is going to happen in our understanding of the errors or the impact of the errors on the heading indication. So let's see if there is any difference or not. Compass on a westerly heading 270 in the southern hemisphere. For an acceleration error, it underreads. Compass card is clockwise and apparent turn is towards the south. The compass in the southern hemisphere during deceleration on a westerly heading will overread. Compass card, you will fill in the blank, and apparent turn will be towards the north. Students, try to visualize it. If you have any questions, please feel free to share. I can show you a couple of more examples if you want. But you will require some self-study, I would say, on these to master these easily. Okay. Generally, I say attending the lecture is enough for certain concepts. Certain concepts you have to revisit it a couple of times at least, not more. Notes, your notes revision, and you always have access to replay this particular part of the lecture every now and then. Students, you can try and message in the Zoom chat box also, okay? Send it to the host only. Acceleration error on a westerly heading, apparent turn towards south. Good, Rohita. Overread, underread, underreads. So be very careful with that also. Okay. Now let's look at heading west, southern hemisphere done. Let's look at heading east. 0900 magnetic in southern hemisphere. Okay. Let's see if the exact reversal is happening or not. Be very careful. What will happen to the compass reading? Any guesses? Southern hemisphere 0900. Easterly heading in the southern hemisphere. What will the compass do? Underread or overread? Any guesses? Please in the Zoom chat box give your guess. Let's see. It's a 50-50 chance of being right or wrong. So I think you should take the risk. I don't mind if you get it wrong, and you should also not feel bad if you've got it wrong.
I think overread, sir.
Zoom chat में डालो ना बच्चा जो भी आंसर है, ताकि दूसरे इन्फ्लुएंस ना हो अपने आंसर से। तो पता चला गुलशन आंसर दे रहा है तो सब लोग गुलशन का आंसर कॉपी करेंगे फिर, इनको पता है गुलशन ने काफी पढ़ाई करी है। सो लिखित, ज्योत्सना, प्रेरित, I've got your answers. Gulshan, I've got your answer. क्या हो रहा है? आप लोग पिजन में आंसर लिख के भेज रहे हो क्या? एड्रेस तो पता ही क्या मेरा आपके पिजन को? ऐसे तो वेबसाइट पे है। Students, no more answers. I think you can only message me today. You cannot message anyone else. आज तो excuse होना ही नहीं चाहिए। भेज दिया आपका मैसेज। क्या श्रीधर?
Sir, I have sent you the answer.
कहाँ भेजा है? मुझे मिला नहीं यार।
Host.
गलत भेज रहे हो आप। दूसरे वाले पे भेजो ना। होस्ट पे नहीं आ रहे तो दूसरे वाले पे भेज दो। ट्राई करो। दोनों पे भेज दो। एक पे तो आएगा मुझे।
सर एक ही अवेलेबल है।
Sir, I'm not getting the second one.
हाँ, and I'm not getting your answers also. मुझे प्रेरित का, गुलशन का, ज्योत्सना का, लिखित का आ गया। श्रीधर तुम्हारा पहले तो आ गया था।
Sir, but अभी
क्यों नहीं आ रहा?
वो सेकंड ऑप्शन नहीं है, सिर्फ होस्ट का ऑप्शन दिखा रहा है।
होस्ट मैं ही हूँ। होस्ट कौन है? और होस्ट कौन एंटरटेन कर रहा है आपको मेरे अलावा यहाँ पे? गिव मी आंसर्स इन द व्हाट्सएप चैट। ट्राई अगेन एवरीवन वंस। जूम चैट जिसने नहीं भेज पा रहे हैं। आई थिंक मुस्कान, सुचिता, श्रीधर, ट्राई इट वंस मोर। हाँ, प्रेरित का कैसे आ रहा है? प्रेरित आपको कैसे मिल गया?
सर मेरे में बस ये एक ही ऑप्शन है और वो होस्ट का ही है।
आप लोग को अलग होस्ट क्यों दिखा रहा है यार? सम ग्लिच इन द सिस्टम। हाँ, आई शुड कंप्लेन। लेकिन जूम का कस्टमर केयर कभी कभी अच्छा है, कभी कभी इट्स वेरी, दे आर नॉट हेल्पफुल, वेरी मच। वी पे देम सो मच ऑफ मनी, sometimes they are not helpful, sometimes they are helpful. So let's see. I'm taking your answers on WhatsApp. Rohita, I've got your answer. Nukul, I've got your answer. श्रीधर आंसर अच्छा, वेरी गुड। श्रीधर ने तो चैट का इमेज भेजा है। ठीक है। मुस्कान, आई हैव गॉट योर आंसर। सुचिता, आई हैव गॉट योर आंसर। आई थिंक सबने भेज दिया है। ज्योत्सना के डायग्राम भी बहुत अच्छा है। वेरी गुड, कॉन्ग्रेचुलेशंस क्लास, जीनियस हो आप। सब लोग ने करेक्ट आंसर दिया है। वाओ, इतना कॉम्प्लिकेटेड टॉपिक इतनी जल्दी इतना अच्छा आंसर दे रहे हो आप लोग। आई एम गोना सेलिब्रेट फ्राइडे टुडे वेरी नाइसली। वेरी गुड। Heading on 0980 magnetic in southern hemisphere, acceleration error, compass will overread. Everybody's got it right, 100%. I like this. Now, सब लोग top करना चाहते हैं. I like that, And you will write compass card or the magnet assembly. Remember, asterisk डाल दो, compass card or the magnet assembly. It's going to be the same thing. बट ये एक्सेलरेशन एरर में मैग्नेट असेंबली की बात नहीं करते, कंपास कार्ड की बात करते हैं वो लोग, बट टर्निंग एरर में मैग्नेट असेंबली की बात करते हैं. सो इधर उल्टा है, बट मीनिंग सेम होना चाहिए आपके लिए. द कंपास कार्ड विल बी एंटी क्लॉकवाइज. सो रिलेशन अगर हम देखते हैं, अंडर रीड क्लॉकवाइज, अंडर रीड क्लॉकवाइज, ओवर रीड एंटी क्लॉकवाइज, and again overread anti-clockwise. This is a secret again. कहीं भी आपका magnet assembly or the compass card it is anti-clockwise, then your compass will overread. Simple. तो ये और अच्छे से आपको याद हो जाएगा. But logical understanding is much better, I would say. Apparent turn north, easterly heading in the southern hemisphere. Apparent turn is towards the south. Sixth point about deceleration error. The compass will underread the compass card. Statement is true. I would just want you to read it in the text and then add it. We already know the answer to this. Everybody knows. But एक बार check कर लेना. वही है कि reciprocal वाला confusion है. And apparent turn is towards the north. Now, another shortcut to understand what or how to decipher apparent turn. Okay. The seventh point will state that. So our headings are done. East-west in the northern, east-west in the southern. Those are the 4 permutation combinations. Good for us. We know the compass card direction of movement. We know the, what do we say? Overread, underread. We know the apparent turn also. Point number 7 talks about apparent turn. Okay. So you'll write acceleration error causes apparent turn to the nearest pole. Now check. Southern hemisphere, our apparent turn was south in the southern hemisphere, and in the northern hemisphere was north and north. Why? Because like I said a few minutes ago, in the northern hemisphere, the influencing factor would be the nearest pole, which is the northern pole. So the apparent turn will be towards that. In the southern hemisphere, the influence will be with respect to the southern pole. So the apparent turn would be towards the southern pole. Another shortcut. We won't call it shortcut. We would just say that, okay, better ways to memorize 16 different points through just a couple of sentences like that. It's like revision on revision on revision. So acceleration error causes apparent turn to the nearest pole. So in southern hemisphere, acceleration error will give me apparent turns to the southern pole, or apparent turn to the south. In the northern hemisphere, the acceleration error would give me an apparent turn to the north. Simple. Questions will be like anything. Mark the correct statement, mark the incorrect statement, fill in the blank, choose the right fill in the blanks, 3 fill in the blanks. They'll try to confuse you, students, just with the language of the question. So be ready for that, okay? Deceleration error causes apparent turn to the farthest pole. So in the northern hemisphere, if I'm having deceleration error, then the apparent turn will be towards the south pole, which is the farther pole compared to the north pole. Let's see if it stands true. Deceleration error in the northern hemisphere, apparent turn south. Deceleration in the northern hemisphere apparent south on both headings, east or west. Deceleration error in the southern hemisphere on a westerly heading apparent turn north. Deceleration error in the southern hemisphere for a easterly heading also apparent north. So these 4 statements I've said can be like 4 questions to you, students. So if you understand it, you'll always get it right. Good for you. Write down point number 8. Acceleration error maximum near poles. Same point we have written earlier. And 0 at magnetic equator. 8th point, deceleration error also max near poles and 0 at magnetic equator. They're talking about the latitude on which the pilot is flying. If one of the pilots is flying on the equator, same heading, and if the other pilot is flying on 45-degree north, same heading, then which pilot will encounter more acceleration, deceleration errors? The one who is on 45-degree north. The one on the equator will have 0. Comparatively, let's say Nukul is flying on a latitude 25-degree north. Then he will have lesser acceleration, deceleration errors. The rules will apply according to the northern hemisphere east-west, what we have seen. But compared to Prerit flying 45-degree north on 45-degree north, Nukul will have lesser errors compared to Prerit. That is the meaning here. Both errors, acceleration and deceleration. The rules will vary with respect to the flow that we have made. So this is with respect to latitude. The question could be which latitude will experience more acceleration error. It will be like, sir, latitude to sikaya nahi. So look for the latitude which is closer to the poles. Okay. Remember that, okay? You can write at, lat, near poles and 0 at equator. DE, deceleration error max at lats, near poles. Now you know latitude is also included here. Good. Ninth point is again a common point. Magnitude of acceleration error or deceleration errors. Magnitude. Of course, it's maximum on the northern side or minimum on the equator, we know. But there would be a question or sometime points would be discussed talking about magnitude. What is the magnitude of these errors depending upon? Intensity. Whether the error is huge or less, what does it depend upon? Common points, okay? Same. Same point for both. So do not be confused in the exams if they only talk about deceleration and error, deceleration error magnitude and tell you what is acceleration error magnitude. It's going to be the same. Magnitude. The impact would be the way we have studied in the flowchart again. That's the difference. Write down first point. The magnitude will depend upon heading. We already know easterly, westerly heading, it will be maximum. Northern or southern heading, it will be 0 or minimum. So heading. Second point, you could say magnitude of acceleration. If acceleration is less, the error will be less. If acceleration is more, error will be more. Let's compare a pilot flying from 200 knots to 250 knots. Let's say Sushita is doing that. And let's compare that I'm also flying. I'm traveling to 250 knots or reaching 250 knots from 150 knots. So my magnitude of acceleration will be more because I have to accelerate through 100 knots, while Suchita's magnitude will be less. She'll be accelerating only to 50 knots. So my errors will be more, her compass error will be less, provided we are on the same heading, same latitude. If she's on a higher latitude, I'm on a lower latitude, then she will encounter the latitude-wise higher acceleration errors, but magnitude of acceleration-wise lower acceleration error. I'll encounter magnitude of acceleration-wise errors higher, latitude-wise lower. So combined probably will have similar errors in our readings, but we'll only get to know once we land back and talk to each other and compare if we have recorded the headings like that, if you are on different latitudes. So that is the meaning here. Okay. And the difference, what would be the error in the difference? Difference in the reading only, students. Either I'm reading correctly, either I'm reading extra, or I'm reading lower. That's it. Next, you will write magnitude is also depending upon design of magnet assembly or the sensing magnet assembly. Please do not get confused now. Questions, they could use any adjective. And the magnitude also depends upon the magnetic latitude. Magnetic latitude, magnetic equator. Remember, in the questions, options would be simple: true equator or true magnet, true latitude. You will be like, yeah, navigation charts, it's always true, so I'll mark true. No, no, no. Impact on the magnetic compass would be with respect to magnetic meridians only and magnetic latitudes only and magnetic equator only. So variation will always be there on your charts. So variation is something you'll have to apply if you're using compass. But at least deviation will be secured for you if you are using remote indicating magnetic compass. But in remote indicating magnetic compass also, you'll come across a situation when you'll know that it itself corrects itself. So what you see is what you follow. Simple. Take a moment, go through these points. See if you have any doubts. After this, we have to do the other errors. Write one point. Note impact of acceleration error or deceleration error is lesser than the impact of turning errors. So what is more important for us to know is turning errors. Acceleration also, turning also. Turning takes more emphasis. Why? Think about it. Why? Students, any questions? Write this point. That is, TE will write turning error are in-class short codes, okay? Turning errors are more significant than acceleration errors. Acceleration, deceleration, same. Because turning error magnitude is greater than acceleration error magnitude because of increased or higher displacement, in bracket you will write deflection or deviation from required heading. Okay. Because of the increased or higher displacement of the magnet assembly. So comparing with the displacement or deflection of the magnet assembly in acceleration errors, the turning errors give more displacement. So the magnitude of the error is more. Let's say, for example, acceleration error was giving me a difference in heading by 10 degrees. Then turning errors might give me difference of headings by 20 degrees or 30 degrees, like that. More deflection of the magnetic from the magnetic north. Simple. Because the north-seeking pole will not be pointing to magnetic north. It's like that. Okay. So it is more likely in a turn for the displacement to be higher compared to the displacement in an acceleration or deacceleration. The displacement is the error. Okay. Second reason is turns in flight occur more often than acceleration. And third point, turns in flight are likely to be more prolonged than acceleration or deacceleration. Both will be, and these are the reasons why turning errors are more. Okay. Write down a couple of more points before we go on a break. About turning errors. Turning errors are max when turning north and south. And turning error are 0 turning east or west. Here put an asterisk. On 0 you put an asterisk and write down the asterisk. Some error will exist due the eddies of compass liquid, but will be marginal. This is known as LIQUID SWIRL, liquid swirl. Many students are like, sir, liquid swirl क्या है? Liquid swirl पे questions आ रहे हैं, हमको पता नहीं है. It is just that the compass liquid will create some eddies which will keep deflecting the magnetic compass north-seeking ability from its orientation. That is liquid swirl. Liquid swirling here and there, creating eddies, what we have already discussed. That is liquid swirl. Liquid swirl is not a maintenance procedure. Liquid swirl is not something that we do during compass swing. Liquid swirl is something that will happen during turns. More. So even though on easterly, westerly turns, I'm not getting any turning error because the liquid is swirling inside and creating some eddies that are deflecting my magnetic heading. Some deflection will be there, but it's residual and negligible. So there are two types to understand this, two statements in the exam questions. Either they will tell you turning errors are 0 at east or west. Mark the correct statement, okay? Option 1, turning errors are east or west. Turning errors on east or west are 0. Second option would be turning errors on east or west are not 0 due to the impact of liquid swirl. Third option would be turning errors on east or west are maximum. So here you would say the option 2 is more correct in this situation. Second type of question would be turning errors are, mark the correct statement, maximum while turning east and west, maximum while turning north and south. Or the reversal would be there, maximum at all turns. So you would say maximum while turning north and south is the correct answer. Simple. Now, what is this north and south? I'll just show you. Let's make a blue earth. Huh? Why is it not taking a shape? Yeah, I think it's like this. Again, the same thing, students. This is my North Pole. We'll assume the magnetic North Pole. This is the magnetic North Pole. Okay. For me, turning through north, what would it mean? There will be two ways for me to turn. Okay. Either I can turn like this. This will be turning through north. Or I can turn like this. This will be turning through north. So the upper one that I have made is a right hand turn or a right turn through north. And the lower one that I have made is the left hand turn through north. Okay. Turning through south, how would it look like? This is my south pole. Turning through south, now I imagine what my heading is first. If my heading is also in the southern bracket, what are those brackets again? These are the brackets like we have studied. 045, 315 like this. What is the other bracket over here? 135, 225. So these shaded brackets, it's very neon. These shaded brackets are generally my northern and southern angles or headings, I would say. So there will be variations. Firstly, whether I'm in the northern hemisphere or southern hemisphere. Then whether I'm taking a left hand turn or right hand turn. Left hand, right hand turn from the north and left hand, right hand turn from the south. The right hand turn clockwise measurement would go like this for you in the southern. So this will be the right hand turn for you when your heading is south. Remember. So here, this is with respect to this aircraft heading north. And here I'm showing this with respect to this aircraft heading south. So this turn for me is a right hand turn with respect to this heading. And this turn is left hand turn with respect to this aircraft. Now, if I'm turning right, my directions are going to increase in the southern hemisphere when my heading is southerly. Southern. In the northern hemisphere, if my heading is northern, then going left, my directions are going to decrease. But how decrease? From 045, they will go to 000. 000 is as same as 360. So you will actually see 360, 355, 315 again. So partially it mathematically looks it is decreasing and then suddenly it increases and then decreases again. That is one reversal that can happen. Second reversal that can happen would be going like this. suddenly your directions would first increase 315 to 325, 335, 345, 360. Then suddenly they'll start to decrease. From 360, they'll go to 010, 020, 030. That is again increasing for us. Clockwise, remember, directions clockwise will always increase, anti-clockwise will always decrease. This is one, and again, one another technique to master general navigation, in-flight navigation, and other things. And the reversal can happen for you in a southerly heading. Clockwise, again, you are getting increase. So the reversal is actually not happening if your heading is focused. The reversal will happen when your heading changes in the southern hemisphere. That's it. So these headings that I have made are the basic headings with respect to our cardinal point system. Angular measurement directions are clockwise always. If you do that, be it a northern heading or southern heading, going clockwise, your directions will always increase. Going anti-clockwise, your directions will decrease. The only thing will happen when you change your heading with respect to this particular heading. Now you change your heading and you make your heading like this. And then try to turn through north. So what will happen to you? So that would be one area of exception. If it comes, then we'll be careful about it. Because of the error in the deflection of the magnetic north now. So we have to relate the fundamental logic. If the headings are reversing, not with cardinal point system or angular measurement clockwise directions, but with respect to what is happening to the magnetic assembly, it is closer to the North Pole, and probably the vertical element of the Earth's magnetic field will also play a role here and increase or decrease my errors. So there you don't use the clockwise thing, but you relate with what would happen to the deflection of my magnet assembly and then give your answers. So this is something that we'll be looking at. I'm giving you 5 minutes. After that, we'll take a break from 12:45 to 1:05. Okay. See if you have any questions. After we come from the break, we are going to do turning errors in a similar way where we have done acceleration, deceleration errors. It is interesting. It is easy, but it can be confusing. Of course. Go back to acceleration errors. See if you have got it. If you have got it, then you can leave. Everybody will have to come back at 1:05. Okay. Anyone who's done, who's not having questions, can leave early for the break. No problem. I'll be going at 12:45. Okay, students, let's see you all after the break, okay? Welcome back, everyone. Okay, write down. First point that we're going to discuss is magnitude of turning errors. Okay, something that we discussed in the end for acceleration errors. We're going to start with that. So we'll write down next point about turning errors. Magnitude of turning errors. What does it depend upon? We'll say it depends upon, number one, higher latitudes where Z, that is the vertical component of Earth's magnetism, is stronger. So higher the latitude, higher the magnitude of your turning error. Okay. Higher the Z component, higher the magnitude of your turning error. Amount of turn itself, similar to amount of acceleration, deceleration. Duration of the turn also. Students who have done a lot of general navigation, try to recollect if you have come through situations where we call rate 1 turn or rate 2 turn. It takes 1 minute to complete a turn or 2 minutes to complete a turn. Generally, 2 minutes is an ideal time to complete one turn. That also we can say for 360 degrees. So duration of a turn will also impact your turning error. Longer the turn duration, more is the impact of your turning error. Interestingly, magnitude of turning error also depends upon speed of the aircraft. Generally, if we don't mention this, we might only relate speed with acceleration, deceleration. That is not the case. Of course, just like any other error, heading, we already know turning north and south, it will be max. And it will be 0, east or west, opposite to the acceleration and deceleration errors. So remember that point also. And number 6, definitely something to do with compass design. The liquid swirl, pendular suspension, etc., etc. These are the points where your turning error magnitude increases. Of course, everything will increase only, nothing else. Everything will be in direct proportion with respect to the increased magnitude of your turning error. One point we have already written down, turning error are more significant than acceleration errors. Okay, this point. When is the turning error max? North and south, 0, east or west. Some variation will be there with respect to liquid swirl. We know what liquid swirl is. Here heading, you will write north and south max in bracket, east and west 0, just as another reference for you. So turning through north and turning through south will be you are only on the northerly heading or the southerly heading, like that. Next point you will write down. Note, an aircraft is easier to steer via a southern heading in the northern hemisphere. Now, this is what I was talking about in the diagram. This red aircraft that I have erased right now, if I want to turn and if I want to minimize my turning errors, then instead of doing a northbound turn, even though I'm in the northern hemisphere, I should do a southbound turn. This is the meaning of this statement. So let's say that I am at a heading of 045 and I want to get onto a heading of 315. So the shorter turn will be left turn for me. But in order to avoid the errors, the least error would be if I turn southerly from, that is 045 to the bigger circle till 315. That would reduce the turning errors for me. If I'm going from 045 to 315 via the northern, then I'll experience a lot of turning errors. This is the meaning of this statement. Aircraft is easy to steer via a southerly turn or southerly heading in the northern hemisphere compared to a northerly heading. This is just to avoid the error. Remember that. Okay. So this is that reciprocal thing that can happen over here. Next point you can write down. Turning error is worst at higher latitudes. Why? Because of the increase in the Z component. About liquid swirl, liquid swirl moves the magnet assembly in the direction of the turn. A very simple yet important point. Somebody tells you, if you're turning right, in which direction will the liquid swirl deflect the magnetic assembly? You'll say, if I'm turning right, liquid swirl will deflect the magnet assembly in the direction of the turn only. It means it will deflect it to the right. Deflecting right, it will mean overreading only for us in this case. Clockwise, the directions are increasing that way. So you'll have to connect all the dots carefully and then give your answers. Next important point, please write down. Turning through north in northern hemisphere. Okay. Liquid swirl can increase the magnitude of turning error. This is why the statement is justified that turning through south in northern hemisphere will reduce my turning error. Interestingly, you might think so the same is true, right? For the southern turn in southern hemisphere. Write the statement down. This is the other reciprocal thing. turning through south in southern hemisphere liquid swirl reduces the magnitude of turning error. Remember this. Students, read these points carefully. This point, okay? This point, you just change this hemisphere and write NH only over here. Turning through south in the northern hemisphere, liquid swirl reduces the magnitude of turning error. Okay? Write down note. Opposite effect happen in southern hemisphere. Now, when you'll be going through the textbook notes, students will be have to very careful about looking at keywords only. I have tried to highlight the keywords from where I'm going to give you the notes, but still you'll have to be very careful to first focus on keywords only. The other thing, what is happening to the CG, the pivoting, right, left, and all, you can leave it for later. Understand this, okay? Give me a second, read through these points, and then we'll talk about different headings and different errors, overreading, underreading, clockwise, anti-clockwise. That's it. 1 second, okay? I'll be just back. Students, the upcoming part is very simple, but you'll have to be very alert and make sense of it. Till the time you cannot make sense of it, I suggest you keep looking at it, keep comparing it with the diagrams that I've made earlier. Try to make your diagrams and then come with it. Preet and Nukul, nice to see you all. Other students, what's happening, For Nukul and Prerit, I can definitely guarantee, apart from a couple of more students, but a few students, I'm still not sure if your videos are off and if you're studying or not. Just saying, I'll not take names. I'll tell you in person. You can assure me. You say, sir, don't worry, I'm studying. I'll believe you. One, two, three, four. 4 points we're going to write down 4 points, and I'll be giving you one more numerical example also. A very simple example. See if you understand. All right. Let's consider number 1 in Northern Hemisphere. In Northern Hemisphere, turning from, or wait, right like this. Turning left from 045 to 315. Make sense, students? It actually means what? It actually means this is my Earth, this is my North Pole, South Pole, magnetic axis. My aircraft is aligned like this, and it is going to turn from here, that is 045 magnetic, and it is going to take a left-hand turn, and it wants to turn till, let's say, 315 magnetic. As a pilot, when you are navigating, you will keep taking directions from your air traffic controllers. Give me my track, give me QDM, give me heading, give me this, give me that. They will tell you, okay, you turn left for so and so, turn right for so and so, and then maintain that particular radial or particular track or particular heading. So you'll be given a lot of instructions to turn right, left. In RT, you learn that. Especially you learn it first time in your ADC clearance compliance. So you are somewhere on a particular heading or track or radial. Any one thing can be considered. Let's say one heading, and then they ask you to turn left and change the heading. And if your present heading is 045 and they have asked you to turn left to intercept a new heading that is 315, then you know this case is being applicable to you. The only thing you'll have to check is whether you're flying in Canada or whether you're flying in Australia, which you'll obviously know. What I'm trying to refer as whether you are in the Northern Hemisphere or Southern Hemisphere. So that idea you'll always have, unless you're flying cross country. Correct? So realistically speaking, you will know which hemisphere you are. You will know your present heading. Let's say your present heading is 180. And they tell you to turn left to intercept a new heading, which would be 145. Then you will say you're turning left again. But are you going to cross the South Pole or North Pole in that case? No. You're moving away from the South Pole. So your turning error would start reducing only by the time you reach 140 on a left turn. Here we are talking about errors induced when you have to cross either of the poles via your turn. What could be the other situation? If I'm at 315 and if I have to intercept 270, am I going to cross any poles? No. If I turn right, that will be a bigger turn. Obviously, nobody is going to waste so much of fuel. So they will give me a smaller turn on the left. Again, my turning error will not be a major factor because it will keep reducing by the time I go to 270. So these points that we are discussing are those points where major turning error is happening. Are you getting me, students? But you can consider turning error in all cases. Questions can come in all cases. We teach you these points, textbooks teach us these points, syllabus gives us these points because this is where the maximum impact is happening. So as a student, you should know that, okay, that's why these examples are given to me. And these examples then become set references for you to compare other things. Okay. So this is the situation in the northern hemisphere. I'm making a magnetic equator over here. So this pilot has to travel 90 degrees, right? To the left, a 90-degree turn. If I won't have any turning errors, then I will start turning. Turn will happen. So let's say this is 045. I don't know where the 747. I got it. I thought somebody took it on a ride. So this thing, yesterday I was not getting it, Today it's there, parked like this. It was parked. One of its tail fin is gone completely. Its nose landing gear is gone. Let's see how long it will survive. It's one of the engines is gone. I just realized. कौन लेके गया था इसको? गुलशन आप लेके गए थे क्या? क्या है ये सब? इतना रैश? हाँ, इतना स्क्रैचेस प्लेन पे? By the way, students, yesterday I had a dream where one of the students teleported his academy airplane to my campus. In my campus, I have a hangar also, apparently, in my dream. And I was like, wow, how was this possible? And my plane, which was a new plane in my campus, got transported to him. I was like, how did he do it? I don't know. But in the dream, it looked realistic. So that plane was broken plane. And I was looking at the plane. I'm like, आप लोग का flying इसमें हो रहा है? आप क्या कर रहे हो? And I was very happy कि चलो ये पुराना plane and let's try to turn it on and all. So I got couple of kids who had come on a visit in the campus in a dream, okay? And I made them sit. That चलो बच्चे लोग आप लोगों को थोड़ा simulation कराता है. The kids sat. I was there checking the propellers. It was like a turboprop twin engine airplane. And just before I could tell one of the kids, don't touch any buttons. One of the kid, I don't know which button she pushed, and something like a propeller started moving in the cockpit itself. And the little kid was just this much away from the periphery of that. And I was like, oh my God, am I going to see an accident? And I'm like, that little kid, stay away, stay away. And there were so many sparks here and there. And I was trying, like, why are you touching? It's a live aircraft. And I was thinking, why would I ask a kid in an aircraft in the first place? And then somehow it got stopped and the kids ran away, scared. Okay, I was like, good lesson for the kid, And then I called in some senior from somewhere. He came and I'm like, see, there are some issues. Can you fix it? And I like watching such dreams, It was a very nice dream when we see airplanes. And just day before yesterday, also I had an airplane dream where I, along with my colleague from past and one other girl colleague, we were in a plane that IL-76, and it was straight a scene out of Mission Impossible movies. So we had to jump, and the girl colleague was flying the plane. And I was surprised to see her fly the plane. I didn't know she could fly. I'm like, good. And we had to jump from 1,000 feet, me and my other friend. And I'm like, thoda aur niche le le, plane. And I can see the grass fields and everything. The cargo door is open. And it's all very realistic, okay? And moments before the jump, we're going on a rescue mission or something, okay? Moments before the jump, I tell my colleague, Arey, this is my first jump. At least tell me how to operate the parachute. And he's like, you just pull it. And I realized I'm not wearing a parachute. So I'm like, please give me a parachute at least before we jump. And this colleague of mine, he gives me a waist jacket and tells me, ye tera parachute hai, chale ja. And I realized he's just bluffing me. It is not a parachute. And he's thrown away all the parachutes. And he wants me and my colleague to die so that he can come out as a hero. Imagine I'm seeing that in a movie, in a dream. And I'm like, I'm not going to be fooled by you. So I go into the cargo holding and I look for another parachutes and I don't see parachutes. I see one life jacket, which is used for water landings, like the inflatable jacket. I'm like, I don't know what to do, but I'm so confident that I will jump and I'll survive. So I'm telling the pilot that, "Oh, थोड़ा नीचे ले ले, और थोड़ा नीचे ले ले. We'll jump and we'll survive." I realized she's not there in the cockpit at all in the pilot seat. And I, where is she now? And finally, I don't know, we jumped. And finally, I could see is that only me and so one guy was the villain, I would say, and me and the other girl, we were the heroes, we would say. And we were coming out of a jungle with all torn clothes and everything and bruises, and we survived. So that was a dream. When I woke up, I was in shock. I'm like, okay, that was a dream. So it is very good, when you're totally into, so when I'm totally engrossed in doing nothing but just academy work, I get aviation dreams and they're so realistic. Some of my desires to do some adventure get fulfilled in my dreams only. I don't really have to go out and travel anywhere. So yeah, I don't know why I shared it, but yeah, two back-to-back dreams of aviation. Yesterday one was very scary. The other one, which had to be scary, I was so confident. Even without parachute, I jumped and, and I survived, So yeah, but it was all realistic, All laws, principles, everything was realistic. Everything. Nothing was fake, is what I'm trying to say. Everything you could have, if you would have been there in the dream, you could have said, "Sir, ये तो principle of aerodynamics के हिसाब से accurate देगा आपने." मैं बोला, "Yeah, see." Otherwise, we imagine the dream to be very hypothetical or very fictional, right? But that was not the case. So it was nice, Sometime when we are done with navigation and we're having revision sessions, you can also share such stories, okay? So let's come back to reality, which is also good, considering it's a Friday. Earlier days, we used to say Friday lectures are fun Fridays, Well, these days, I've stopped saying it because we're just focused on studies. But I think New Year, we're going to do that again, fun Fridays. So this was the fun aspect that I shared with you all. I hope you enjoyed. So coming back, in the Northern Hemisphere, when I'm turning left, so the keywords here are turning left. And I know my northerly heading bracket is always from 045 to 315. And this is the turn that I'm supposed to take. What will be the indication of my compass? Will it underread or overread? What is the pilot supposed to do? In this case, the pilot is supposed to take an action. Let's say this is 045. I want to turn to 315. I'll bank left and I'll start turning like this, like this, like this. I'll keep looking at my magnetic compass. From 045, my magnetic compass will show me 360 or not. And then it will start showing me 350, 340, 330, 320, 310. By the time I see 310, I'll expect myself to level out. And then I level out and then I continue flying. So I've done a good turn. The problem is my compass is not this accurate right now because I'm taking a turn in the Northern Hemisphere, crossing the north. So what am I supposed to do as a pilot? I'm supposed to be aware that because of the impact of the magnet assembly and however the reason is that my compass is either underreading or overreading, whatever the compass magnet assembly would be, clockwise or anti-clockwise, either my reading will give me overreading or my reading will be underreading. If my compass is overreading, it means if I'm at 0, let's say, if I'm at 010, and if the compass is overreading, it means 010 is extra to what I am on. That is the meaning of overreading. Again, let's say I'm turning, and now on the compass, I see north. Then what I see on the north is overreading. It means I'm not on north yet, but my compass is showing I'm on north yet. So that is overreading. It means I'm slightly before north. It could be 010, 020. Again, if I'm turning, and if I'm just putting that if there, if it is still, the principle will tell us overread or underread. Let's say it's still overreading. By the time I reach 315, am I on 315? I'm not on 315 because 315 is the overread. So it is extra. Extra to what? Anything that is lesser. Do I need to be anything that is lesser than 315? No, I need to be on 315. So how will you be on 315? by purposely overshooting your alignment on the runway, not on the runway, on the compass card or the compass heading. So in order to level out on 315, I might go up to 330 on the compass and then level out. It means if it is 330 overreading, it means I am somewhere close to 315. I want to be on 315. This is the meaning of pilot wanting to overshoot, means pilot should overshoot his or her desired heading if there is overreading. And if there will be underreading, then the pilot should undershoot. Undershoot what? Not the runways in this case. The leveling out from a turn. Right hand turn, leveling out, left hand turn, leveling out. Generally, when you'll start flying, you will face a lot of difficulty in doing this. This is one of the most difficult tasks when you learn flying or even when you're doing simulations on computers. Leveling out on the required heading is always not correct, and you seem to wonder it's your fault. It's actually not your fault. It's the fault in the compass. So you should know what is your orientation of the turn, which hemisphere you are in, and then you know either you roll out from the turn, rolling out, or level out from the turn either before your desired reading of the heading or after your desired reading of the heading. That is the meaning of overshoot and undershoot. I'm going to give you these statements in a very simple way for you to understand. Starting with the first situation when I'm in the northern hemisphere turning left from 045 to 315. Write down. Point number 1, movement of magnet assembly or compass, whatever, all things are the same, moving. The movement of the magnet assembly or compass is sluggish. You often see this word with respect to hydraulic controls also. Sluggish means it has a lag. It is slow. It has some more resistance. It is not free. It is not lively. Okay. Compass reads. Will the compass underread or overread? The compass will overread. Here sometimes students think sir sluggish है तो ये overread क्यों कर रहा है, underread करना चाहिए. That is not the way to connect dots. That is not the explanation here. The resulting factors would be something else. This is the impact. This is the symptom. Questions come with respect to sluggish or lively. Questions will come with respect to overread or underread. Okay. Magnet assembly movement, or I can say in this case compass card movement also, asterisk, for you to know the meaning is same. But here they will use magnet assembly. In acceleration error they use compass card. So magnet assembly movement, is it clockwise or anti-clockwise? It is anti-clockwise. Students, anti-clockwise overread. Have we seen it anywhere before? Have we seen that in acceleration errors? Or have we seen the opposite? Check, check, check. Anti-clockwise overread. Do you see? The same relationship is still there. This is a secret. This is like a password for multiple answers. Does it stand true in all cases? You can only determine once you have written down all points and compared, but so far it looks true. This is something that you should verify when you're doing your self-study through notes also. Leveling out or stopping the turn. Okay. Compared to my required heading, should I level out before I reach the required heading, or should I level out after I reach the heading? It means, should I undershoot? Should I overshoot? My required heading. Remember, required heading. Leveling out or stopping turn to align with required heading, and in bracket right, and as compared to required heading, should it be early or late? Easy, write down. Leveling out should be early. It means, if in other words, I have to say, pilot should undershoot or overshoot required heading to stay on required heading. See, trick, huh? Undershoot. It means you level out early. It means in our case, if I have to level out on 315, when I'm turning from 045, I should level out the airplane by the time I reach 295, not 295, going like this. Maybe 335, 330, 325, or 320. Anything that comes before 315. So that undershoot, overshoot, you do not confuse with the which number is bigger or which number is lesser. Otherwise, you'll make the same mistake that I made. The 315 से छोटा तो sir 270, 2980 होगा ना. But your look at your turn. What will come first? That will be a level out. So the best way to not confuse ourselves here would be to write down. This will be 035, 025, 015, 000, and then probably you could say 360 minus 15 would be 345. So this is the trick here. If you just go on numbers, students, you will make mistakes. 335, 325, and then I have my 315. So I will level out early. It means I'll start leveling out either on 335 or on 325 as the case is with respect to the magnitude. But I'll level out early. Simple. When I level out early, by the time I have leveled out, I'll see that my required heading and my indicated heading will be correct. If I don't do it, if I do it on 315, by the time I've leveled out, my actual heading would be more than 315. That could be 320, 325, 335. Then you're not on track. Even 5 degree, 10 degree off track is a big deviation, students. Big deviation. We don't need that much of deviation off track. See the trick question. Question. While turning left through north from 045 for a desired heading of 315, you will level out at which indicated compass heading. Option A 335, option B 315, option C 295. Please give me answers in the chat box or WhatsApp chat. First, try chat box once more. If I don't get it, I'll tell you. You can just copy paste it in your WhatsApp chat also. If you just relate it with our basic logical reasoning of number system, then you'll get it wrong, student. Then you are not focused in the class. Then you have not worked enough with respect to attention on what I'm showing you right now. What is early and what is late? If you just go with the numbers, then you will always go wrong if you don't focus right now. This is the first step where we need to focus. If you remember this, rest everywhere you will be easily getting correct answers. Don't jump to give the answers before verifying, which will be the earlier heading to roll out, because I'm rolling out early. Which will be earlier heading from this? Will it be 335? Will it be 315 or 295? Understand, you're going from 045 to 315. Which will come first? 295 is not going to come at all. 315 will not come because we have turning error. Although the question is not talking about turning error at all. We have to infer that. Early will be 335 only in this case. Whoever is giving me 295, क्या हो रहा है? जो मैं पढ़ा रहा हूँ वो क्यों नहीं पढ़ रहे हो? खुद का ही करना है तो फिर क्लास क्यों अटेंड कर रहे हो? I'm being a little stern, nothing else. Sridhar, do you have a doubt? गुलशन, तुम्हारा क्या प्रॉब्लम है? सब कुछ सामने सामने दिया है, क्यों दे रहे हो गलत आंसर? श्रीधर, तुम क्यों दे रहे हो गलत आंसर?
नो सर।
नो
सर मैंने वैल्यू गलत लिख दिया।
अच्छा
Option
गुलशन, नुकुल उस दिन नुकुल को क्या बताया है मैंने? सोच समझ के आंसर देना है, राइट? तो क्या वो तुम्हारे लिए एप्लीकेबल नहीं है? या तुम्हें वही सब याद है जो पहले से पढ़ रखा है? चॉइस तुम्हारी है भाई।
सर ऑप्शन सही था सर, वैल्यू को मैंने जल्दी जल्दी मिली।
अब मेरे को तो प्रूफ नहीं है ना। हाँ, ऐसा ही बोल रहे हो, प्रूफ है। तो ये मिस्टेक्स होती है, एग्जाम में मत करना बच्चा प्लीज। लैक ऑफ फोकस। ऑप्शन ए सही है, बट ऑप्शन ए का वैल्यू क्या है? एज अ मॉडरेटर मैं गलत चीज ही उठा के रखूंगा ना आपकी। मेरे को तो रिस्क नहीं चाहिए। ये एविएशन ऐसा है जहां आपकी पॉजिटिव्स नहीं देखेंगे, अगर नेगेटिव्स है तो नेगेटिव्स देख के उनको इंप्रूव करेंगे हम लोग। नहीं तो लाइफ में चलता है भैया, आपका पॉजिटिव अच्छा है, नेगेटिव को चला लो। एविएशन में हम वो नहीं रिस्क ले सकते, इसलिए पासिंग परसेंटेज भी 70 के अगेंस्ट है। नहीं तो हम तो 35 33 के यूज टू रहते हैं ना। आई थिंक वो सिस्टम में ही प्रॉब्लम है हमारे भैया। दिस इज समथिंग वी ऑल से, राइट? सिस्टम ही खराब है। इट्स नॉट अबाउट द सिस्टम, इट्स अबाउट आवर ओन अंडरस्टैंडिंग नाउ, नो मैटर व्हाट द सिस्टम सेज। मुझे 70 भी दिया है, फिर भी मैं 70 नहीं, मैं हमेशा 100 के लिए एम करूंगा। दिस शुड बी माई सिस्टम, बिकॉज आई वांट टू बी द बेस्ट पायलट। आई वांट टू रिटायर, आई वांट टू रिटायर एज अ वेरी सक्सेसफुल पायलट। ये तुम्हारा अल्टीमेट गोल होना चाहिए। कैप्टन सली के लेवल पे रिटायर होना है मिनिमम, ऐसे सोचना है आपको। दैट वुड बी योर अल्टीमेट गोल एक तरफ से, लुकिंग फॉर अ जॉब। तो श्रीधर, नो क्या होता है? डाउट डिस्कस करना है?
सर आई एम नॉट गेटिंग इट।
ये सब मैंने पढ़ाया ना, ये सब के पॉइंट्स रीड करो अच्छे से। तुम्हारी गलती नहीं है, तुम्हारा पुराना कैल्सिफाइड थॉट फॉर्म, पुरानी ट्रेनिंग यहाँ इंटरफेयर कर रही है। तुम्हारी गलती नहीं है, अब तुम्हें थोड़ी मेहनत करनी पड़ेगी यहाँ पर। श्रीधर, कर रहे हो मेहनत? तुम्हारे लिए वेट कर रहा हूँ।
यस सर, रीडिंग।
हम्म ये तुम यहाँ पे ध्यान नहीं दे रहे हो डायरेक्शंस पे। मैं अगर लेफ्ट टर्न ले रहा हूँ 045 से, तो कौन से डायरेक्शंस आएंगे सीक्वेंस में मेरे? 315 तक पहुंचने के लिए कौन से पहले आएंगे? 035, 025, 015, 000, that is 360, then 345, 335, 325, and then 315. इतना समझा आपको?
सर नाउ आई गॉट दैट 3 to 5।
3 to 5 तो ऑप्शन में है ही नहीं यार।
मतलब 335 पहले आएगा टर्निंग।
यस यस। आप अभी भी अंडर रीड को क्या सोच रहे थे? 315 से जो छोटा है वो नंबर ले लूंगा मैं। अंडर रीड तो तुम्हें याद था, बट तुम्हें
यस
2905 छोटा लग रहा था। बट यहाँ पे 2905 आ ही नहीं रहा है ना। हमारा टर्न देखो और पहले क्या आ रहा है। दिस इज दैट रेसिप्रोकल कंफ्यूजन। आ गया ना? इसको मार्क करके रखो, इसको 2-3 बार स्टडी करना आप
यस
अच्छे से याद हो जाएगा आपको। बस ये सेम ब्रेक के बाद का सेम सेशन भी कर लोगे। वो ड्रीम वाला स्किप कर देना, बार बार क्या ये ड्रीम सुनोगे मेरा। उसके अलावा आप दोबारा से ये करोगे तो आपको समझ आ जाएगा। नहीं भी समझा तो मुझे बता देना। Students, one more thing, whenever you're not getting a concept, the trick is trace through all the steps from starting to beginning. You'll find one place where you've got it wrong in the steps. If you fix that, you'll get the correct answer. That is your job as a student, as a pilot. I will teach you every now and then, but ultimately, I would want to see you try to do that on your own only. That is the greatest learning I can give you, my students. बाकी ये सब तो कोई भी सिखा सकता है, right? In the end, टेक्स्ट बुक्स में तो लिखा ही होता है। स्टडी कैसे करना है वो अगर कोई सिखा दे तो इट्स लाइक टीच अ मैन टू फिश एंड ही विल नेवर गो हंग्री। Man, woman, everyone, provided they are eating fish, you know. I'm cracking a lot of jokes today. I'm very happy to see सब लोग अच्छा आंसर दे रहे हैं ना, तो मुझे अच्छा लगता है, मैं खुश हो जाता हूँ। Explanation will be all these points only. Refer points above. It will take some time to understand it, not necessarily, but possibly. चलो अभी नेक्स्ट गियर में जाते हैं। आज भी थोड़ा वो शूट हो रहा है आपका लेक्चर, खत्म करेंगे अपन, ठीक है? सेकेंड एस्पेक्ट इज टर्निंग in the northern hemisphere, turning right from 315 to 045. In northern hemisphere, turning right from from 315 to 045. I'll give you the rules and then I'll give you one numerical. You give me the correct answer. Point number 1, movement of the magnetic assembly. Is it sluggish or is it lively? Okay. Magnetic assembly movement, it will be sluggish only. इसलिए मैं आपको बोल रहा हूँ, that's why I'm telling you all, don't directly assume everything will be opposite. Only few things are opposite, few things are same. Study them and remember them carefully. Magnetic assembly will be sluggish. Second point you will write, compass reading, will it overread or underread? Here your compass will underread. It means आपको अगर 045 पे होना है एंड आप 045 पे लेवल आउट कर रहे हो, तो आपका कंपास 045 नहीं दिखा रहा है, कम दिखा रहा है। इसका मतलब आप कम पे लेवल आउट कर रहे हो। तो यहाँ पे अगर आपको 045 पे होना है तो आपको बड़ी वैल्यू पे होना होगा, विच विल रिप्रेजेंट यू आर एट 045. In English, under read means, let's say you want to be on 045. If you align or roll out at 045 after the turn, then the compass is under reading. It means it's actually not on 045. It is higher. So you have to roll out either before or either late. Let's see that, okay? Compass reading, under reading. Third point, magnet assembly movement, clockwise, anti-clockwise. Any guesses here? Verbally बोल सकते हो आप अपना guess. You can give me the answer verbally. Magnet assembly movement, clockwise or anti-clockwise?
Clockwise.
Clockwise, sir.
Good guess. Very good. So clockwise will go ahead with underread, anti-clockwise with overread is one thing that we are seeing everywhere. If we finish all points, only then you determine the conclusion, okay? Point number 4. Leveling out or stopping the turn. Should we level out or should we stop the turn early or should we stop the turn late? Early. In this case, students, the number scheme will match with respect to lower number and higher number because you're going clockwise. Right hand turn. Fifth point, pilot should undershoot or overshoot required heading to stay on required heading. Okay. Leveling out early in this case, undershoot. Earlier also it was undershoot, here also undershoot. Here the numbering is going to be varying, different. Sixth point, example, question example, write down. If desired heading is 045 in northern hemisphere from present heading of 315 turning right to stay on desired heading, pilot has to level out on dash 025 045 065. Any suggestions with respect to your answers? Clockwise was correct in that regard. Here, what is my correct answer? Is it 025? Is it Zoom chat only have one answer? I'm expecting 4 answers of Zoom chat. WhatsApp chat, I've got 1 answer. I'm expecting more answers. Come on. Good job, Sridhar. श्रीधर यहाँ पे वो लॉजिक सही है, हर जगह वो लॉजिक शायद नहीं चलेगा, उतना हमें ध्यान रखना. श्रीधर, रोहिता, गुड जॉब. ज्योत्सना, गुड जॉब. प्रेरित पूरा आंसर दे दो ना. प्रेरित, गुड जॉब. या चेतना.
So can you scroll the screen slightly up?
Sure. You want the question?
Right, sir.
मुस्कान, वो लॉजिक लेफ्ट टर्न के लिए था, राइट टर्न के लिए नहीं है. राइट टर्न के लिए कौन सा हमारा डायरेक्शन पहले आने वाला है? रोलिंग आउट अर्ली करना है हमें. करेक्ट, वी नीड टू रोल आउट अर्ली. अभी क्लॉकवाइज जाओ 315 से, पहले कौन से डायरेक्शन आने वाला है? 315 के बाद 325, 335, 345, 360, 010, 020, 030, 040, 045। तो 065 तो आएगा ही नहीं ना, पहली बात। तो हम अभी भी कंसेप्चुअली इसको नहीं देख रहे हैं। हमें एक चीज याद हो गई तो हमें लग रहा है ठीक है, नंबर बड़ा होना चाहिए, बट अंडर रीड में नंबर बड़ा होना चाहिए। नो नो नो, अंडर रीड में नंबर तब बड़ा होगा जब आप लेफ्ट हैंड टर्न ले रहे हो क्रॉसिंग द नॉर्दर्न पोल। व्हेन यूर टेकिंग राइट हैंड टर्न, तो मैंने आपको बताया ना, डायरेक्शनल तो इंक्रीजिंग ऑर्डर में होंगे आपके सारे। तो वहां पे वो मैथ आपका लॉजिकल मैथ को मैच करेगा, बिकॉज इट्स क्लॉकवाइज। कार्डिनल पॉइंट्स, डायरेक्शंस इंक्रीज फ्रॉम रेफरेंस नॉट 360 डिग्रीज। सो प्लीज करेक्ट योर आंसर स्टूडेंट्स। जिसने भी गलत आंसर दिया है उसको करेक्ट करके लिखना है। आई नीड द हिस्ट्री। चैतन्य, सुचिता, योर आंसर्स हैव नॉट गॉट। लिखित, योर आंसर हैव नॉट गॉट। व्हाट्स हैपनिंग?
So can you flash the options again?
Rohita, Sridhar, Nukul, Muskan have got it. Muskan, let me know if you're confused. Prerit, Jyotsna have got it. Others have not given it. Nukul, you have not given it. सुचिता, आप भी है ना, आप भी व्हाट्सएप पे भेजो आंसर्स। एंड आप चेक करो आप कौन से इन्विक्टस एविएशन को भेज रहे हो। मुझे लग नहीं रहा है होस्ट वाले को भेज रहे हो अभी भी। दो होने चाहिए जनरली। वो आप लोग को पार्टिसिपेंट्स में जाके ट्राई करो सेंड करने का, चैट में तो शायद नहीं दिखेगा आपको। पार्टिसिपेंट्स में जाके इन्विक्टस एविएशन होस्ट को सिलेक्ट करके मैसेज भेजने का ट्राई कर सकते हो। ठीक है, आज का तो हो गया। करेक्ट आंसर सुचिता, लिखित करेक्ट आंसर। चलो ठीक है। चैतन्य, तुम्हारा रह गया आंसर।
But I have sent it.
कहाँ भेजा है मेरे को याद? तो आप व्हाट्सएप करो ना चैतन्य, आपका भी जूम पे नहीं आ रहा है, सो सॉरी। आई एम एक्सपेक्टिंग योर आंसर ऑन व्हाट्सएप। या
Yes.
वर्बली दे दो आप, तो अभी सबका हो गया।
So 065.
पता नहीं आप क्या पढ़ाई करते हो चैतन्य, वीडियो भी ऑफ है। अभी मुस्कान के लिए मैंने एक्सप्लेन किया है। आप कहाँ थे और क्या कर रहे हो?
Sorry, sir, it will underread.
अंडर रीड है तो 065 क्यों बोल रहे हो आप?
Yes, 025.
नहीं, एक्सप्लेन करो यार। तुम यहाँ पे रह जाओगे, तुम्हारे दिमाग में वही रहेगा। पायलट को भी अंडर शूट करना है, लेवल आउट भी अर्ली करना है, सारे हिंट दे रखे हैं। 065 क्यों लिख रहे हो बताओ? वो पहले वाले ही फंडा याद रख लिया क्या दिमाग में? अभी सारे उसी से करोगे, बट वो तो लेफ्ट हैंड टर्न के लिए था ना, राइट हैंड टर्न के लिए नहीं था। चैतन्य जल्दी बताओ।
Yes, sir, it would be
आई एम टेकिंग
025.
एवरी एरर इन पर्सन। आप अकेले नहीं हो, श्रीधर का भी लिया, मुस्कान का भी लिया। बताओ जल्दी।
Yes, sir, it would be 025. It will underread. And
Why
we will-
025? Leveling out early. Why 025? Why
So
not
because
065?
we will move right side
Uh-huh.
towards the right, and 025 will come first
First with respect to what?
with respect to 045.
Required heading. Very good. दो सही वर्ड्स बोले आपने। समझ आ रहा है कि नहीं आ रहा?
Yes, sir.
स्टूडेंट्स प्लीज छोटी छोटी चीजों में घाई मत करो। अगर अभी गलत पढ़ लिया ना, ये जिंदगी भर आपके दिमाग में गलत ही रहेगा। आप कितना भी मेहनत कर लो, आपको गलत ही चीज समझ में आएगी, सही नहीं समझ आएगी फिर। सेम थिंग दैट हैपेंड विद नॉर्थ एंड साउथ, सेम थिंग कैन हैपन हियर आल्सो। बी वेरी केयरफुल। यार ये सब चीजें मैं 10 मिनट में डिक्टेशन देके खत्म कर सकता हूँ यार, मेरा टाइम बचेगा ना। इतना मैं मेहनत कर रहा हूँ तो वाई यू टेकिंग इट फॉर ग्रांटेड? आपको लग रहा है सर टाइम पास कर रहे हैं स्टूडेंट्स? If I'm spending 10-15 minutes on one topic, it means it has something to learn. If you don't learn in those 10-15 minutes, what's the point? Right, students? Please be careful, okay, everyone. Write down point number 3. Be very careful, okay? You can take some time to give me answers. But आप लोग अगर distract हो रहे हो, disturb हो रहे हो, if you're getting distracted, disturbed, if someone is bothering you, you can tell me first answer. I've missed this part. Sir, I'll go through the recording and then give you answers. At least take ownership like that. It is your class. You're allowed to speak up. Don't forget that. Third case is, again, now leave your assumptions aside, everyone, okay? In Northern Hemisphere, turning right, okay, from 135 to 225. So students, they are talking about aircraft is in the Northern Hemisphere. What is 225? And what is 135? This is 135. This is 225. With respect to directions, the aircraft will be turning from this alignment, that is 135, just look at it. Is it a right-hand turn? If this is the case, this doesn't look like a right-hand turn. It means my heading is not this. My present heading could be different. Okay. What would be my present heading? Carefully look at it. How would I do a right-hand turn in the Northern Hemisphere if I have to go from 135 to 225? I want you to take a couple of minutes and try and plot it. How can I take a right-hand turn in the Northern Hemisphere Is it possible? Changing from 135 to 225. Can it be done through a right-hand turn? Yes. Can it be done in the Northern Hemisphere? Right-hand turn? Why not? This is right hand only. Carefully, if I look at it, from 135, I'm only turning right with respect to my pilot's heading only. From 135, if I turn right, I'll align my aircraft on 225. It's possible in both places. It's possible in Southern Hemisphere also, other hemisphere also. No issues whatsoever. 135. Look at the pilot's perspective. It is a right turn only. For 225. From 135, turning right for 225. Any confusion? When we initially look at it, it looks like something is wrong. But then we carefully look at it and we realize nothing is wrong. If you're thinking, sir, why have you made parallels here when the directions? So I'll show you. The technique to master directions is always to make your cardinal points like this. Okay. So you get your east, south, west, north. And let's say I have another aircraft that is somewhere here. How do I determine the heading of this aircraft? So wherever I made my cardinal points, they will give me the reference. But how? And remember, this is a technique commanders use in real life on a daily basis for quick calculation of the required headings. Okay, it's that simple. This strategy everybody uses. So what do? We check our heading. Okay, we see this is the track. And then we make a parallel line to this from our cardinal points like this. The line should be parallel. Once that is parallel, you measure it like this clockwise. cardinal points clockwise, directions clockwise from reference north, you get 135 magnetic quickly. Let's say there's another aircraft like this. How do I determine? I can simply take this heading line and make a parallel over here, this arrowhead, and then take this angle here. So I'll get 225 magnetic. Another technique is to get your cardinal points right. Let's say there's another aircraft over here. When I say cardinal points, you understand cardinal system. It's actually this hexadecimal system gives you directions clockwise from reference north. If this is it, if at the aircraft you want to determine your heading, then you check for your CG. Generally, we will consider this point as your CG. And then you check the orientation of your north on your chart. If the orientation of your north on your chart is like this, let's say true directions in this case, then from the CG, you make a parallel line with the north. Then you extend your heading line like this. And then the same rule, clockwise from reference north, like this. This will become your 315. In this case, magnetic. We are saying here variation is 0. So true and magnetic are the same. You'll always need one reference, students. Two ways to determine a correct heading if you know the north. And your compass will at least show you north if nothing else. This is actually how your compass headings are read out on your indicators also. Simple. So the third situation in northern hemisphere, turning right from 135 to 225. This turn. But my heading is this, that's why it's being right turn. So my heading would become like this. So I'm turning right. So it's on my right turn right now. Are you getting it? So what is point number 1? Who can help me? I don't want to scroll up again and again. Point number 1, magnetic assembly moment. Students, help me with the title of the point. Answer I'm going to give you. Magnet assembly is lively. It's not sluggish. It's more free to move compared to the actual readings is what we are meaning over here. Second element, compass reading, is it?
Yes, sir.
Yes.
Chalo, thank you. Compass reading, overread or underread? Overreads. It means compass is overreading. So wherever I want to be, the compass will show me extra if I choose that to roll out. It means I'll have to roll out early probably, or maybe later. I don't know. Let's see. Let's figure it out. What is the third element?
Magnet assembly movement.
Thank you. Magnet assembly movement, or you can also add rotation. Anti-clockwise. Is the relationship between anti-clockwise and overread also maintained here, students? Is it still the correct thing happening everywhere? Overread, anti-clockwise, overread, magnet assembly.
Yes, sir.
Yes,
Very
sir.
good. Very good. What is the fourth element?
Leveling out or stopping the turn.
Thank you. Leveling out or turn stop. Late. Late. What does it mean then? It means if I want to be on 245 and if I level out at 245, then the compass is overreading on 245. It means if it is showing me 245, I'm not on 245. 245 is the overread of my actual. So probably I'm actually at 225 or 215. So in order to be on my desired heading, I'll have to overshoot the heading because my compass is overreading. Overreading means my actual heading will be lesser than the indicated heading now. Now you can compare it with this statement also. Overreading, somewhere you can write down overreading would mean, in this case, my actual heading is lesser than the indicated heading. So to be on the actual heading, I'll have to level out on a higher heading to get a desired heading. But you can keep it like this also. What is the fifth element? Overshoot, undershoot.
Yes, sir.
Overshoot, undershoot with respect to the required heading. What will you do? Overshoot or undershoot your required heading, students?
Overshoot.
Late will mean overshoot only. Students who are not confident, take some time, read through it and you will get there. चैतन्य समझ आ रहा है? कंफ्यूजन हो रही है?
No, sir. समझ आ रहा है.
नो सर मतलब समझ आ रहा है? नो सर. अच्छा. कंफ्यूजन हो रही है?
No, sir.
अच्छा. ठीक है, मतलब ठीक है. कुछ है तो पूछ लेना है, ठीक है? टाइम पे ही पूछ लेना है, प्लीज.
Yes, sir.
वेरी गुड. स्टूडेंट्स, कभी कभी मुझे भी इनिशियल में कंफ्यूजन हो जाती है. व्हेन यू डोंट डू इट मच रेगुलरली, the mind will always try to show you something else, but then you like, okay, you take a picture memory, you have your checklist, keep an open book, keep revising. The more you see and repeat it, the easily it will get into your mind. There are many ways to master a topic, but don't mug up things unnecessarily, because वो भूल जाएंगे हम फिर. If required heading is 2 to 5 and turning right from present heading of 135 in northern hemisphere, considering turning error, aircraft has to be leveled out on which of the below mentioned indicated compass heading. Option A, option B, and option C, you will write 205, 215, 235. Chaitanya, answer? Would you want to give an answer?
Yes, I'll guess.
श्रीधर, आपने दे दिया आंसर. वेरी स्विफ्ट, वेरी फास्ट. प्रेरित ने भी दे दिया आंसर. रोहिता हैज आल्सो गिवन द आंसर. लिखित, नुकुल, गुलशन, ज्योत्सना, सुचिता. गुलशन, वेरी केयरफुल, नाइस. केयरफुली आपने ऑप्शन नंबर एंड ऑप्शन वैल्यू सही लिखा. आंसर सही है कि गलत है वो नहीं बता, कंफर्म करो. ऑप्शन तो करेक्ट लिख लिया, चलो पहला हर्डल पास हो गए. और आंसर सही है कि गलत है? मुस्कान ओके, रोहिता ओके. नुकुल, चेक करो अपना आंसर. क्यों ये आंसर दे रहे हो, सोचो थोड़ा. अभी जस्ट नोट्स दिए हैं. लेट करना है. लेट कंपैरिजन टू व्हाट? लेट कंपैरिजन टू माय रिक्वायर्ड हेडिंग ओनली. माय रिक्वायर्ड हेडिंग क्या है? 2 to 5 है.
Yes, sir. Yes,
options-
I got it, sir. Yes. Sorry.
अरे मेरे को अरे सॉरी नहीं बोलना है, अपने आप पे ध्यान देना है, हमारी कंफ्यूजन कहाँ है। सॉरी सॉरी नहीं, ठीक है। सॉरी मेरे को सिर्फ आप तब बोलना चाहिए जब आप कोई जानबूझ के गलती कर रहे हो। लाइक ये क्या अनुकुल, क्या अच्छा, बी और ए कौन सा लूँ तुम्हारा आंसर? अरे नुकुल अच्छे से देखो यार, रिक्वायर्ड हेडिंग क्या है, पहले कौन सी हेडिंग आएगी, बाद में कौन सी आएगी, रॉन्ग पे रॉन्ग आंसर क्यों दे रहे हो? और मैं जब समझा रहा हूँ तो मेरे को रोक दिए। रिक्वायर्ड हेडिंग 2 to 5 है, आपको ओवरशूट करना है, 2 to 5 के ऊपर जाना है ना, आप राइट जा रहे हो ना, किधर आपका हेडिंग क्या है? स्टूडेंट सी लाइक दिस, पहले आपका 135 है, फिर धीरे धीरे आप टर्न लोगे तो आपका बाद में क्या आएगा, 145 आएगा, फिर आएगा 155, फिर आएगा 165, फिर आएगा 180, फिर आएगा 195, 205, 215, 225, 235 तो बाद में आएगा ना। तो आपको कौन सा चूज करना है, पहले वाला या बाद में वाला? लेट लिखा है ना यहाँ पे।
Sir, overshoot 1-3. Above
ओवर
1.
शूटिंग 2 to 5, तो 2 to 5 यहाँ पे कैसे
2-5.
ओवर शूट है? मेरे टर्न का डायरेक्शन पे फोकस रखना है मुझे, ये टर्न है मेरा। सो अंडर शूट होता तो मैं 215 या 205 पे लेवल आउट कर सकता था, ये तो ओवर शूट कर रहा है। चैतन्य आंसर आया तुम्हारा? नहीं आया अभी तक। चलो ठीक है। नकुल क्या कंफ्यूजन है? इंडिविजुअल पॉइंट सीख रहे हैं, इंडिविजुअल पॉइंट्स को सीखना है, जो पहले सीख ले उसी के आधार पे हमें आंसर नहीं बनाना है। यहाँ पे हमें जो पढ़ाया जा रहा है वो समझ के उस पे आंसर देना है हर एक सीक्वेंस में, नहीं तो मैं हर एक सीक्वेंस पे इतना टाइम लूंगा ही नहीं ना आप लोग को समझाने के लिए। करेक्ट आंसर इज 245 बिकॉज इट हैज टू बी लेट आफ्टर ओवरशूट 2 to 5 के। एक ही ऑप्शन मैच हो रहा है यहाँ पर। नुकुल क्या कंफ्यूजन है?
वो सर समझ गया अभी।
ठीक है, अच्छी बात है, समझ गए। कंफ्यूजन क्या हो रही थी वो तो बताओ।
सर कंफ्यूजन इज वो लेफ्ट राइट वाला हो गया वो। एक्चुअली सदर्न हेमिस्फीयर।
हम हेमिस्फेयर तो नॉर्दर्न ही थे,
यस
हमारा
सर, यस
खुद
सर।
का हेडिंग 315 है, और मैं 315 से 2 to 5 जा रहा हूँ, तो क्लॉकवाइज ही घूम रहा हूँ ना मैम।
राइट सर, राइट।
तो कंफ्यूजन क्या है?
सर डायरेक्शन जो है डाउनवर्ड्स थी, सदर्न
हम्म
हेमिस्फीयर तरफ थी, तो इसलिए
हम्म।
कंफ्यूजन हुआ है सर।
Students, remember, if you're moving clockwise, your logical increase of directions is logical only. चैतन्य, मेरे को हाथी आके क्या बोला, व्हाट्सएप पे भेजना है ना चैतन्य, पहले भी बोला था। नहीं आ रहा है जूम चैट पे, सॉरी, कोई इश्यू है जूम का। वर्बली दे दो फिर से, भूल गए क्या
चार्ली
पिछले
2-3.
क्वेश्चन में क्या हुआ था? छोटे छोटे इंस्ट्रक्शंस क्यों नहीं फॉलो कर रहे हो? चलो लास्ट पॉइंट। This is the only example in southern hemisphere. Turning right from 135 to 225. सेम सिचुएशन है, बस हमारी एयरक्राफ्ट सदर्न हेमिस्फेयर में आ गई। अब हेडिंग हमारी प्रेजेंट हेडिंग, आर प्रेजेंट हेडिंग इज 135 ओनली, but our aircraft is in Australia right now, we could say southern hemisphere. Earlier my aircraft was somewhere in the north. यूरोप पकड़ लेंगे हम लोग। हेडिंग रेफरेंस इज सेम for both of us. ठीक है, just the hemisphere has changed. So be very careful over here to note down all the points. Point number 1, Magnet assembly movement, sluggish or lively. Write down sluggish, slow चल रहा है. Second point, compass overreads or underreads. The compass is underreading. So can anyone guess what is the direction of rotation of magnet assembly or the compass card, clockwise or anti-clockwise?
Clockwise.
Clockwise, sir.
Yes, very good. चेतन आपने दिया था क्या लास्ट आंसर? कि श्रीधर ने दिया था?
No, sir.
गुलशन,
प्रेरित.
प्रेरित, very good. So इसके बाद we can say whenever the magnet assembly is moving anti-clockwise, the reading would be over-reading. And when the magnetic movement is clockwise, the reading would be under reading. ये shortcut होगा आपका. ये notes में specify किया, मैंने highlight भी किया. Clockwise. The fourth point was turn, stop. Okay. Level out or stop turn. Late or early. Stop the turn early. Under read कर रहा है ना, तो early. मतलब आपको अगर 045 अगर आपको 225 चाहिए और आप 225 पे लेवल आउट कर रहे हो, तो उसका मतलब वो 225 पे नहीं है. इट इज अंडर रीडिंग, सो इट माइट बी ऑन 245. ये स्टेप्स ही आपको केयरफुली करेक्ट आंसर देंगे विद रिस्पेक्ट टू लॉजिकल अंडरस्टैंडिंग. डायरेक्ट अंडर रीड ओवर रीड पे आंसर नहीं ढूंढने जाना है, आई वुड से, अनलेस यू हैव मेमोराइज्ड इट. तो आप बोलोगे कैसे, चलो 225 पे जाना है ना, अंडर रीड कर रहा है, तुरंत आंसर नहीं मिलेगा. अंडर रीड कर रहा है मतलब 225 पे अगर लेवल आउट करता हूँ तो मुझे कम डायरेक्शन दिखा रहा है, बिकॉज इट्स अंडर रीडिंग. तो अगर मैं 245 पे जा रहा हूँ और लेवल आउट कर रहा हूँ, तो वो मुझे अंडर रीड कर रहा है. अंडर रीड कर रहा है मतलब एक्चुअल डायरेक्शन इज द मोर डायरेक्शन, एक्चुअल हेडिंग इज द मोर हेडिंग. जब तक ये आंसर नहीं आ रहा है तब तक तुम्हें सोचते रहना है कि क्यों नहीं आ रहा. ये तो डायरेक्टली योर माइंड कैन जस्ट प्ले द वे इट्स प्लेइंग विथ मी राइट नाउ. इफ आई एम पुटिंग माई सेल्फ इन द स्टूडेंट्स माइंडसेट राइट नाउ, ओके, अंडर रीड मतलब क्या? So I should relate this point. Under read means if I'm on 2 to 5, then the reading is lower than the actual heading. That is under reading. It means my actual is more. ये पॉइंट मेरे को समझना है. इसका मतलब 2 to 5 पे लेवल आउट कर रहा हूँ तो मेरा एक्चुअल ज्यादा है, मतलब देखने में 2 to 5 लग रहा है टर्न पे, बट मैं एक्चुअली रोल आउट कर रहा हूँ 235 या 245 पे. दिस इज द मीनिंग ऑफ अंडर रीडिंग. जनरली हमें उसका उल्टा ही समझता है. जब हम थक जाते हैं, जब हमने रिविजन नहीं किया होता है, जब हम पैनिक करते हैं एग्जाम सिचुएशन में, these errors can happen. The human error can go against your training. So you make your own strategy, make your checklist. To go through the checklist, you will get the correct answer. Students, एक एक mark important है. Ask the student who's got 68, 69. They will tell you. On a tough exam also, they'll tell you 3 months, 4 months I studied so hard. 2 marks. The paper was so good, I gave 80, 85 answers correct. If you get a response like that, then you know the student knew the answers. The student ended up making silly mistakes. If you avoid silly mistakes, you will gain 15 marks. Do you know this, students? If you avoid silly errors, you will automatically increase your score by 15 marks. So getting 85 is very easy. That's why I say it's very easy. If you avoid silly mistakes. If you study everything and avoid silly mistakes, 90, 95 is very close to in your grasp. So it's okay. You will get there with practice. Level out or stop the turn early only because it's overreading. ज्यादा रीड कर रहा है वो, आप उस पे जाओगे तो आप ओवरशूट खुद कर जाओगे आपके रिक्वायर्ड हेडिंग को, तो आपका डेविएशन यार ऑफ ट्रैक हो जाएगा, वो आप उतना उतना ऑफ ट्रैक नहीं होना आपको. लिखित, दिस लिटिल बिट ऑफ हिंदी, आर यू एबल टू अंडरस्टैंड और नॉट?
No, sir.
Sorry,
I could not understand, sir.
nothing, not even little bit.
Maybe some, sir.
Don't worry, I have translated almost everything. But I was just checking, you know. So if you don't understand, then you should tell, okay? Anything that is not translated, at least be on the alert saying, sir, please translate. You can have your translate emoji somewhere, reaction. You can specify that. I'll see that and I'll be like, okay, yes. Second last point. Pilot should undershoot or overshoot the required heading. At what heading should he or she level out? At a lower heading than required. It means lower heading than required, lesser heading than required, earlier heading than the lower and lesser can confuse us in reciprocal tracks. So we say early. That's why they say early. They don't say less or lower. Early. But आप इतना ध्यान रखो, you just focus on this much, that what are the directions that are going to come first. Then choose the earlier one. That's it. So you just need to have good clarity about the directions you're going to cross one by one with respect to your direction of flight. Please give me your answers in the chat, WhatsApp chat. Likhit, Jyotsna, and Gulshan and Prerit, you can give me on Zoom chat. Everyone else, please drop it to me on WhatsApp chat, okay? The question that I'm going to ask you out. For required heading of 225, turning right from 135 in southern hemisphere, or I can say in latitude 35 degrees south. Okay, questions would come with respect to meridian and latitude also. You'll have to decipher, okay, it's a southern thing or it's a northern thing. Two variations for a similar question, two different answers. Right, students? At lat 35 degree and 131 degrees east, it doesn't matter. Meridian will not take any impact over here, only the latitude. South, okay? Pilot should level out at option A, option B, option C, 225 degree indicated heading on a compass, okay? 245 degrees indicated heading and 205 degrees indicated heading. For you, if you are memorizing, just memorize early or clockwise or underread or undershoot any one point and you will get all the correct answers for all different variations. Up to you. You choose your own. I would say you nicely study and remember everything to make it much more easier for yourself. So whenever you're learning to practice and solving in class and your study session, self-study, keep an open book and solve. Okay? Chaitanya, very quick to give answers. Very nice. Chaitanya and Sridhar. Likhit, Jyotsna, Prerit, and one more student I'm expecting in the chat box. That will be Gulshan. So Likhit, Jyotsna, Prerit, and Gulshan. Correct answer. And Nukul, good job. Sushita, good job. Rohita, good job. And Muskan, good job. Sridhar, Chaitanya, excellent. All these are magnetic only, so I'm not putting that. Be on the alert for that in your questions. Good. Now, after some time, I'll be sharing study notes with you all. In that, I've highlighted a lot of points. You read them carefully, add to their own notes. Other points that we have not highlighted, you can skip them, read them once, but try to fill in the blank from your notes that I've given you by reading the notes carefully, okay? You might at times confuse thinking, sir, something wrong is given to me from what you have thought, but that is not the case. So be careful, read it again, and you will get the correct answer. One thing that I'm not covering in class is the, what do we say? The properties of a compass liquid. Okay. The properties of a compass liquid is a very small paragraph. Read it and add to your notes. The properties would be that it should have a low coefficient of expansion. Because of temperature changes, the liquid should not freeze or not expand unnecessarily. This is one of the reason why in the chamber of the compass, there is a special kind of tube being used, which allows for the expansion of the liquid of the compass. It's called siphon tube. It's highlighted. Remember that. Something called viscosity. A compass liquid should have low viscosity. It's there in your notes. Your compass liquid should be highly transparent. It should not be muddy. It should have a low freezing point. It means it should not turn to ice easily. It should have a high boiling point. It should not boil or expand also easily. And it should be non-corrosive. Simple. There are two reasons why compass liquid will give us problems. One is when it would expand or contract unnecessarily. We rectify for this mistake by using a tube. This is called siphon tube. Expansion error. And by taking a good quality compass liquid with the points that I've just said, you will get a reference to read. Second error that happens is because of the liquid swirl. Liquid swirl will deflect the magnet assembly in the direction of the turn. Liquid swirl is because of the induction of eddies, I would say stray waves that would impact or deviate my sensitive magnet assembly. Okay. Note liquid swirl is due to viscosity of liquid. So when we use lower viscosity liquid swirl will be minimized comparatively. Okay, that's it. Don't make a big deal about liquid swirl otherwise. Any questions? Anything you'd like to add, discuss, request before we wrap up? You have 2 days of break time. Use them wisely, refresh. Next week is going to get a little heavier with respect to your studies. We are also going to introduce RT for Delhi students in live lectures, plus increase studies on MET because we have missed a couple of MET lectures. And of course, doing radio nav for navigation also. That is the priority for the next week. So I'm thinking of scheduling in a way that one day we can dedicate to a particular topic, especially MET, so that we can cover up nicely. But then lengthy lectures are going to be there with a good amount of break in between. So you'll be mentally prepared for that. Chaitanya, if there is any variation in your schedule, do message me after the lecture, or is it the same? Other than that, I don't have any requests.
It is the same only.
Yeah, fine. Anybody has any other request, you can tell me. Anybody who's willing to start lectures a little early in the morning. Students who cannot start earlier than 11 a.m. for live sessions, do let me know. You can give me your minimum starting time also. I'm just saying, let's see. I'll try to send you all the schedule by tomorrow itself so that you're mentally prepared from Monday onwards. And I'm going to introduce a lot of tests also now for y'all to practice. Some of y'all who have done up to lecture 16 or you'll be doing up to lecture 16 for NAV, side by side, you know you have done a lot of questions. But students have already studied so much till lecture 42, 43, 44 right now. For you, it will be a good revision to give tests. You can appear for the test anytime you want or when I give it to you, provided you are done with learning and studying. So a lot is going to be on our plate. Let's see how it goes. We cannot compromise on quality. Other than that, if you'll need anything, just drop me a message or schedule a call. And if there's something pending from my end, just drop me a message and remind me on that. So I'll take some time and schedule the same with you. Okay, students? Okay. And evening lecture, we are giving a holiday today, everyone. So you can study your navigation, or you can do relaxation or revise navigation. Whoever is going to attend the live lecture 3 to 5. It is a holiday, so you enjoy that. You can relax or cover up your missed lectures. All right. Thank you for extending time. I'll make sure that in future we try not to extend times. So don't think I'm getting used to it just because we have done it couple of days. But if you tend to do it, feel free to tell me. If you cannot attend, you can always leave. And in your free time, you can continue. Okay, students. Thank you for being a nice class. I'll see you when I see you next. Take care, everyone. Taking
Sir,
your
is there
leave.
any update for RT?
Thank you, sir.
Most welcome. नुकुल आ जाएगा 1-2 दिन में अपडेट. उम्मीद रखो आ जाएगा. मैं तो डेली चेक कर ही रहा हूँ.
Sir, I'm also checking every day, but
आप चेक मत करो, आप रिवाइज करो, पता चल जाएगा. डोंट वरी.
okay, sir.
है ना. आप बस रिवीजन पे ध्यान दो. क्या एक्स्ट्रा चाहिए, क्या नहीं चाहिए, मुझसे बात करो. उस हिसाब से हम प्लान करते हैं आगे का वीक. पढ़ाई ज्यादा इंपॉर्टेंट है. एग्जाम डेट से क्या ही फर्क पड़ता है. ऐसे सोचना अपन को. आने वाला है. और मेरे हिसाब से 20 जनवरी है. तो मेरे हिसाब से 9 फरवरी से पहले तो कोई एग्जाम नहीं होगी. जल्दी से जल्दी भी अगर हो रही है तो समझ रहे हो आप. तो वो एक एंटिसिपेशन लेके आप चल सकते हो. चलो स्टूडेंट्स, एनीथिंग एल्स? Others who are done, you can leave the session. Okay.
Thank you, sir. Bye, sir.
Most
Thank you, sir.
welcome.
Bye, sir.
Bye bye, everyone. Take care.
Thank you, sir.
Most welcome, Rita.